recording and then minimize this and also you can see here. See, this is the complete architectural design or an architectural plan. Everything is there. We have to submit. We are usually submitting this kind of drawing in municipality for the approval. Okay, but for today's session, the drawing which is important for us, this drawing which is here, the ground floor plan, or on the basis of this ground floor plan, is it visible? Dimension leave, other thing visible, except dimension, other thing visible. Tell me, volunteer, volunteer, is it visible? कोई बोल ही नहीं रहा. Sure, fine. So for today event, this architectural double line plan is important for us. On the basis of that, we will make the model in STAAD.Pro Connect series, and then after we will design this slab beam column and everything in RCDC. So this double line plan. After this double line plan, we have to make the central line plan. So I will. So I already prepare some plan because otherwise it will takes lot of time. So this is the central line plan already I prepare, and one plan also I have to show, that would be better. This right side is the double line plan, and this left side is the central line plan we had prepared. Central line means the center part of this line or this line. We have just calculated the center part, and this distance we are just measuring and drawing this diagram. Okay, this is the meaning of central line plan. So from this double line plan, we had prepared this central line plan, and on the basis of this central line plan, we will prepare the model in STAAD.Pro. So more information with you, it is very easy to construct the model in STAAD.Pro. So I had also converted this central line plan with the more detailed information which is here. All the dimension from junction to junction is shown here. Okay. Now from for today event, you should just keep the things in mind. Where the junction is there, we will provide column. Okay. And where the line is visible in the central line plan, we will provide beam. It is not correct, but we will go for that. Okay. Otherwise, it will divert from the main things. Fine. Where the junction is there, we will provide column, and where you are seeing the single line, where there we will provide beam. And for us today event, the horizontal member, whatever we are providing, that is beam, and the vertical member, what we are providing, that is column. Again, it is not correct, but for today event, we will follow this. Clear? So we can move fast. All the dimension is there. Now I have to open this STAAD.Pro. So that would be better. On screen, this STAAD.Pro is there. This is select series. So I will remove. This is connect series. So in your organization or in graphic era, we have a license of this STAAD.Pro connect series. So we will use this. Either you have to double click this or right click and run as administrator. So it should be open. It would be open. So maybe it will take time because it is trying to connect through the server. Just simply continue. So just wait for some time. Let me check the recording should go. Otherwise, later you will face problem. I will go little not fast. I will go like that. Whatever the thing is required, I will discuss. Other part, I will keep for you to understand by yourself. So now, when we have started this STAAD.Pro Connect series, the you this kind of window is coming to you. So in that, lot of thing is there. The thing is that we have to start a new project because we had not created any project. So we will go to new and we will just click this new, and here you are getting something. So here you should write the name of your project, whatever the project is there. So I am writing RCC and I am taking G plus 2 building structure. So G plus 2 and this building structure. So building simply RCC G plus 2 building. Now one thing is that going to the next this vacant space where already something is written, you have to select one folder where you want to save your stat pro every time. Otherwise, you will be it is going to be saved by default. So you should not save default. So for that, what you should do, you should create any folder whatever the name you are interested. So I just created an event day and a stat file with the name of a stat file. I created one folder. So I will save all the file in this. So in that case, I will assign from here that folder. So when I am coming, so when like that, it is going somewhere. So technical event, then one day technical event, then event day, and then again stat folder. This stat folder, I will select simply this stat folder and select folder. So yeah, please. So again start recording, fine, pause gone, recording started, fine. So here, so you have to select that folder. I selected already. So every time your all the stat pro work is going to be saved in this folder automatically. No need to copy from here and paste there. Okay. So every time you do this thing, otherwise you will be face some kind of issue with the finding. The select folder, then find. Then after again here the two unit system is there. English and metric by default go for the analytical. Physical I will tell you later. This is related with the classing and other thing. So we are interested in the here the analytical things. Here the English and metric. So we are following the metric system. Select this metric system and keep this blank because it is right now not required. So and just create, click here create. So it will go to the another kind of dashboard or pop-up box. So this is the graphic user interface you are seeing here. This is the graphic user interface you can see here, and here the node means the point. Here the node means the intersection point. Everywhere the intersection point, it is saying about the node. Here you are looking at the node, you can put the value here, it will create the nodes at this white screen. And some parameters, this left side is also the connect series key. You can just make the model here and you can go anywhere from direct from here. That is the benefit of this connect series. Earlier it was not available with the select series. That is the great advantage of this connect series. And one by one, if I will start the model, that would be benefit better. Here the important thing is that you can see this coordinate axis. This is the x-axis and y-axis is perpendicular to this plane, xz plane, and z is this direction. If I am looking, if I have to look from the top, so if I am going to view and I have to look from first, we have clicked, then only it will activate. And what happened? So see here, this is x-axis and this is z-axis. It means whatever the drawing is with us, we have to make this x-axis and we have to make this z-axis, and as per that we have to put the coordinate in this box because our stat pro coordinate axis is like that. Clear? ETAB coordinate axis is different, so we will go when we will learn ETAB, we will follow that coordinate axis. Here we will follow this coordinate axis. X direction is this, z direction is this, and y direction is perpendicular to this. Dot means perpendicular and upward towards your face. Okay, fine. So now I'm going to the drawing center line plan. Already I converted. So from that center line plan, we will try to make the model in STAAD.Pro. So let's see. So I am going to this model here. So it means our x-axis is this. This is our x-axis, correct? And this is our z-axis. And this is the first point origin. The coordinate of this is 0, 0, 0. Correct? So we have one coordinate. Other coordinate, we will find this coordinate, this distance is there. We can find the coordinate, again find the coordinate, and every time we have to put the value in this and it will create the model. Like that you will see. If I am putting here 0, then press tab, it will go to the next column and again next tab to column. So when you will come to second row, you will get the already see here the points has been created. Oh, sorry, some hang is there. Hanging, why hanging? Okay, find the points. It's created, but I am unable to select this point. Correct, now? Not so. I am not unable to select this point. It means key for selection, different cursor is there. So where we will go, we have to select. So go to select and see here node cursor. So this is node. So when we will click node, it is appear with a small dot node symbol. So then now I have to select this. This is the first point. Okay, and this point it belongs to this origin 0, 0, 0. Now I have to I have to make this point. So what we will do? This is the x direction. It means x value is 3.053. Y, don't talk. Volunteer, please take care of this thing. Not no having sound, please. So we have to go to this point, and what is the coordinate of this? 3, if I'm talking in meter, this is in mm. So 3.053, then y value upward 0 and z value 0. Then we have to again put this value here, then we will get the another point. But by this way, if we will do, it means it will take lot of time. Correct? So we will go for the smart way because we are a smart student, a smart one, no? Now, so what we will do? But we will follow the things where every time we are preparing. What we are preparing every time? Copy and paste. Simply, we will use that technique here also, and it will save our lot of time. So how we will do that? So just X and Z I am deleting from here. That would be better. And then simply first have to go to the node cursor. अबे हट जा यार कहाँ गया हटा हाँ now activate the window कुछ हैंग हो रहा है दिव्या जी ये इंटरनेट इशू लग रहा है मुझे कुछ तो लग रहा है एक्टिवेट हाँ हो गया So now I have to select this first. So node cursor, then select. Now Control C, simply Control C and Control V. When I am doing this, this window is appearing. And what is the X distance? X distance was what? 3053, yani 3.053. So X is, because it is in meter, 3.053, and we will not touch Y and Z because it is on X axis. So simply click on OK, it will create the other point. Very simple. Very simple, na? So now the next point is 5410. With respect to this, so select this and then Control C, Control V, and then it is 5.410, and then OK, it is created the next point. Now from here to here, if we are going, so we will select these 2 points and we will move this direction 1755, 1.755. So we have to select this, Control C, Control V. In this time, we have to move in Z direction, 1.755. So it will create the other 2 points. Clear? Now we have to select this 3 point and we have to move this by 3591. So it will create this 3 point. Correct? So we 3.591. 3.591. 3.591. 3.591. So it's okay. Fine. This created. And one more point is there from this point to this point 2.133 from here to here. So we have to select this Control C, Control V, and then we have to go in this direction 2.133. It will create the other point. Clear? Fine. No having sound, please. So now we have reached up to this. After that, we have to select this, and we have to move 4.073. This, we have to select. So we have to select this, and then if I am going to select this, it has been deselected. So what we have to do? We have to select this, then control, and then select other. Then it will select the other point. Either we have to select like this, it will select, drag and select from this side also and from this side also. Or also you can select by just clicking. So clicking point is very difficult every time. With control key you have to click. Otherwise you will click this without control, it will select or it will deselect. Be careful. Okay. With control key you can select the lot of points. So now we have required to select this, then control this, and then control this, control C, control V, and then we have to move in this direction by 4073. 4073 finished now. This something wrong? No, fine, fine. Control C, control V. Where है? अरे इंटरनेट चला जा रहा है क्या क्या हो रहा है Control C, Control V, fine. And we have to move by 4.073. So we have to move in this direction 4.073 and we have to press OK. Then it has been created this point. Okay. So now after creating of this point, again we have to move, select this 3 point and we have to move this direction by 4083. This 2 point we have to move by 4.082. We have to select this two, control C, control V, and then we have to go with 4.082 simply. So it has been created this 2 point, and this point we have to move by 5298. 5298. So we have to select this, control C, control V, and then this direction 5.298. Then, sorry, 5.298, and then click OK. हाँ आइए So now we had created almost 90% of the point model. So now we have to again go from this point we had created, and then again we have to go for from we have to select this point. Sorry, from this we have to also come to this side, and this is 21216. So Control C, Control V, and then 1.12. Sorry, how much? 1.216. Then okay. So it's created. Now we have to select this, Control C, Control V, and then again we have to go this side by 2.061. This is 2.061, and then it has been created by, sorry, Control Z. If you have to go back, it's created wrongly, so you just Control Z, it will go to the undo step, one step back. So we have to select this, Control C, Control V, and we have to put this Z value. Z value is how much? 2.061. 2.061, and then OK. So fine. One last point is remaining, this point, and this is 3277 from both directions. From here also we can go by 3.277. So we have to select this, Control C, Control V, and 3.277. You know, this is the value. Fine. Now, okay. So we had created, please look at here. Please listen. Please listen. We had created all the junction point. Correct? We had created all the junction point. Please reply. If you will not reply, the class would not be interactive. What happened? आपकी आवाज नहीं आ रही पॉइंट दिख नहीं रहा दिख नहीं रहा अरे तो दिख नहीं रहे तो बोलना चाहिए ना ये है तो ये आप लेट आए हो क्या क्लास में तो फिर क्यों नहीं है तो है दिया तो है अच्छा ये नहीं दिख रहा है अभी दिख रहा है अभी दिख रहा है अरे छोड़ पॉइंट छोड़ो ये दिख रहा है ये दिख रहा है ये डायग्राम लाइन डायग्राम ये दिख रहा है ना? तो ये जितने भी जंक्शन है, वेयर द जंक्शन इज देयर, वी हैड क्रिएटेड दिस इन स्टैट प्रो simply, and the value is written here. See, x coordinate, y coordinate. First coordinate is what? This node. This node is 1 0 0 0. अरे भाई देख तो ले अब. 0 0 0. कोई नहीं, रिकॉर्डिंग में सब दिखेगा, टेंशन न ले. रिकॉर्डिंग में हो रहा है ना, उसके लिए देख लियो आराम से. टेंशन. यहाँ आप ये कर लो. अब वो दिख नहीं रहा तो प्रोजेक्टर में गड़बड़ी है, मैं क्या कर लूँ उसमें बता. तो कोई नहीं है, ये जो पॉइंट मैंने बनाया है, द पॉइंट विच आई हैड क्रिएटेड हेयर, दिस इज द जंक्शन ऑफ दिस डायग्राम. इज इट ओके? दिस इज द जंक्शन पॉइंट ऑफ दिस डायग्राम. द लाइन डायग्राम इज विजिबल टू यू ना? हाँ, तो द जंक्शन, दिस इज ओरिजिन, देन वी आर मूव.
आप लोग बातें करने आए हो यहाँ पे? सर बोल रहे हैं, आप लोग चुप के सुन नहीं सकते हो?
This, with the help of this line diagram, we had created the point in STAAD.Pro. Clear? Okay. Are just reply. Okay. This line is okay. This point is okay. With the help of this line diagram, we had created the point in STAAD.Pro. Simply the junction point. And how to create? Just simply copy paste. This is the concept. The copy paste do. This is the simplest way. Okay. Now we have to say like that our structure is G plus 2. G plus 2 means what? G plus 2, if I am saying, so it means ki this is the foundation level, this is the uh, first story, ground floor, this is the second story, and this is the third. Yani G, this is the ground floor, then this is the first, and this is the second, G plus 2. It means this is roof. This is roof, and this is foundation. And I am keeping this distance 2 meter below the ground level, the foundation depth. Okay. And also the floor to floor height I am keeping 3 meter. How much? 3 meter I am keeping 3 meter. It is approximately 10 feet. Okay. When you will convert, it is approximately 10 feet. And 2 feet I am keeping the foundation depth. But when we will do design, we can change also this foundation depth. But for the analysis, we are just keeping 2 meter. Okay. So now we have to go. Now this plan is at the level of this level, plinth level, or you can say like that, the ground level. Now we have to this make this diagram also to the first floor, second floor, sorry, first floor slab level, second floor slab level, as well as roof level, and also we have to create some point on foundation. So there we can fix our foundation with the soil. Okay. So soil we had not created. We will simply assume that our foundation is fixed in the real world. So like that we have to create the things. So okay, just delete this. So now what we will do, so point diagram we had created, so also we have to create this line diagram. As per the given, we have to create this line diagram, and after line diagram also we have to create slab here, because we are going to place slab also. So line diagram is beam, and also we have to going to create the slab. So how we will create? So now point, I am saying we have to create the beam. We have to create the beam. It means we have to create the geometry. So we have to go to geometry. And in geometry, we are interested to first click this, otherwise it will be not going to active. ये इंटरनेट इशू हो रहा है कुछ, क्योंकि एक्टिव नहीं हो रहा. इन ज्योमेट्री यू हैव टू गो टू ऐड बीम, बिकॉज अरे कौन बात कर रहा है यार, इतना क्या दिक्कत हो रहा है, किसको क्यों आवाज आ रही है इतनी? नहीं करना है चले जाओ यार, क्या दिक्कत करो, सारे क्लास को डिस्टर्ब कर रहे हो. एक आधी बात हो रही है जिससे सब डिस्टर्ब हो रहे हैं. हबिंग जैसा साउंड आ रहा है बिना मतलब में. We have to go with this add beam, and because we have to create this line diagram. Here the lot of option is there, midpoint, perpendicular, curved beam, but we are simply interested to join this point to this point. So simply click on this icon. It will come with the beam symbol, and then click to first point and go to next point. It will create the beam automatically. But we are not given the dimension and other properties, mechanical properties or material properties. We will give later. Now we are only creating the line diagram. Again, go to this point and then the next point it will create the beam. My suggestion, always create one direction, then go for the other direction. Now I'm creating in X direction. So all the beam you have to create, all the beam, just one point, go with the other point. And हाँ अटेंडेंस ले लीजिए
पानी वानी चाहिए होगा तो बता देना।
हाँ
पानी वानी चाहिए होगा मुझे बता देना।
ये रखा है बगल में ठीक now we have to हाँ ठीक है सर now we have to create this attach this beam with point to point and it will create the beam. I am interested to create all the beam in X direction, then we will go for the other direction. ये मैम थोड़ा एक आध बच्चा ही है हविंग आ रहा है कोई एक आध बच्चा ही है कोई एक आध बच्चा ही है जो
आप इधर करते जा रहे हैं तो बच्चे पैरेलल करते जा रहे हैं तो अगर कुछ मिस कर रहे हैं ना तो फिर वही जैसे पूछ रहे हैं
नहीं यू
एक बार आप जैसे 2-3 स्टेप करके ना 2 मिनट पॉज दे दीजिए तो लेट देम डू इट
नहीं मैं थोड़ा क्लियर कर इफ यू विल ट्राइंग टू प्रैक्टिस हियर इट इज नॉट पॉसिबल इफ यू विल प्रैक्टिस हियर इफ हाँ
आप साथ में करते जा रहे हो क्या यस तो
हाँ तो ये दिक्कत क्या होगी कि इन 6 आवर इट इज नॉट गोइंग टू फिनिश ओके तो आफ्टर दिस इवेंट आई विल अपलोड दिस कंप्लीट 6 आवर रिकॉर्डिंग on YouTube. You should look at there and practice there. Here you just watch ki what the things are going. Okay. Otherwise, if you will practice here, it is not going to finish in 6 hours. It is impossible.
Still if you want to do it तो आप करो that's not a problem the only thing is if you are missing any step then don't disturb the other person okay if you are missing any step don't disturb the other person because the recording will be available so you can catch up with the recording ठीक है तो don't create that chaos disturbance actually you बहुत हो रहा है okay so no more discussion among yourself just focus on
Look at here now. I am recording. It's a recording is going on. Whatever the recording would be, it would be available with you.
okay not don't worry about it
अभी
simple
बस अभी देख लो आप लोग ठीक है फैमिली में खा रहे हो ठीक है अदरवाइज बस देख लो घर में जाके प्रैक्टिस कर सकते हैं ठीक है सर विल बी शेयरिंग द वीडियो इज रिकॉर्डिंग द वीडियो दैट वी विल share you go home and at your home you can practice the same okay we now just focus on what the super side is used okay आप बस उस पर ध्यान दो सब पढ़ा
I am here. I am available here in the civil engineering department staff room every time, and also I am staying near to this graphic era. So wherever you have doubt related to software, you can ask anytime. You can ask on telephone also. That is not a big deal. Okay, don't worry. This is first day. Okay, so try to just familiar with this software. Don't try to be an expert in this software. Okay, just try to be familiar with this software. Now I am going to the other direction, Z direction, and creating all the beams as per our given light diagram. We had already created the center line plan. Architectural plan, maybe you have to prepare or the architect will give you. So I am assuming that architect had given me this plan and I had just with the help of that architectural plan I created this center line plan and from center line plan I created this model in STAAD.Pro so I can apply the load and other things in this and I have to do the analysis of this G+2 structure. So this model is look like whatever the you had seen here. It is similar like the we had created in this. So this is the easiest way I am telling you. Otherwise, lot of ways available, but this is the easiest way. Copy and paste, and then with the help of add beam, you have to just add this node and create the diagram. Now, I already told you for the today class where we are meeting at the junction. That is our we will provide the column and other the line diagram we are going to be use as a beam. Okay, maybe in real structure or when we will expert we will remove sub column and we can also modify our beam. Fine, but for today to go faster, we had adopted this thing. So this is the line diagram we created. Now I am saying ki G+2 structure and also the ground level is sorry foundation level is there. I assume the 2 meter depth of the foundation, so we have to go 2 meter down. So 2 meter down also it means the column is there and that column name is the pedestal column. So we have to give the dimension of this 2 meter. So again what we will do? Again the thing is there key we have to just select all the nodes and then copy and paste, and in that case we have to put the y direction -2, then it all the point will go down, but it is also very tedious. Then again the line we have to meet one by one. So what is there? There is one tools given in the STAAD.Pro, and that name of that tools is translational repeat. With the help of that translational repeat, we can create the model very fast. So how can we go there? So we have to create, it means we have to go to geometry, and here you can click here in this button. What is written here? Translational repeat, and also circular repeat is option is there, but generate rotation or circular repeat is also there, but for our case this is circular repeat. For our case we have to go to the either x direction or y direction or z direction. So we are moving in z direction, so we can use this translational repeat. We will just click there, so one box appear. Fine. And now we have to move in which direction? X direction, Z direction. We have to move in Y direction. This Y direction is vertically up or down. And we are going to the from ground level to the foundation level, and we are going by default step spacing it given is 5 meters. So we are going in the minus y direction because here minus y is not given. So we have to put here -2. Then only we can go in the minus y direction. Otherwise, it is not possible. So also number of step is one because we are only going one step down. Fine. After that, here something is written geometry or geometry plus property or all. You can click right now anything because we are not provided anything to the structure. Also something is written here link step. You will click this link step, then it will create the column. Otherwise, it will not create column. You have to manually create that column. So that is the benefit, okay, of this translational repeat. Now if I will click, it will not create. Why? Because we are not selected. We are not given command where you have to go. Like that, if I am saying it is up here, please select the member node or other thing. Okay, so we have to select the node. So I am selecting the node. So selection of node, we have to go to select, then node cursor, and then simply drag. It will select all the nodes because this time we are providing the column to each node. Otherwise some node we will remove, it will not provide the column there. Then simply click there, okay, then it will create the node. But I will convert this diagram from plan to 3D, then it would be visualized very easily. So now if I have to go to the, we have to see in 3D, then we have to go to this view, and then this is the 3D symbol. It's, you can create this. This is showing in 3D. By a scroll, you can zoom in or zoom out, and scroll, press and move. So it will convert to hand. You can place anywhere as per your convenience. So now I will click OK, then it will be visible here. So if I am creating, see, it will be visible here. Okay, it's okay. It's come down. So now foundation level we reach. Now the ground level we had created. Also we have to provide the slab. Still the slab is not there. So we have to create the slab to again. So we have to go to geometry. Now add beam like that, add plate is there. So add plate and triangular as well as the, simply if you will click on this, it is rectangular. So we have to provide the rectangular slab. So we will create this. Select this, then it will be appear with your rectangle box. Then we have to, where we have to provide, click the node 1, 2, 3, 4. Then it has created. Like that also everywhere we have to create the plate. 1, 2, somewhere, fine, 3 and then 4. 1, 2, 3, 4. 1, 2, 3, 4. Everywhere we have to create the slab. When we will see our drawing, when you will see our drawing here, where is the complete drawing? At this location, we are providing the staircase. Okay, in this box we are going to provide the staircase here. So either we have to create the staircase here, or at when we, or other option is also there. You have to provide slab here, apply the load, and it will transfer to the beam. And at the time of designing of a stair, we will design in RCDC. So it will save our lot of time. This is a one kind of bypass. You can also create here, but it will take lot of time. So it's better ki we have to provide one slab and apply all the load. It will act like a stair also transferring the load similar way. So slab we will provide, we will apply the load, and again during designing of a stair we will use RCDC, and there we can save lot of time. So here we will use that concept. So also we will provide the stair sorry slab here, slab we had just provided here. So only we had provided the diagram. We had not assigned any kind of cross section or material. Still that is pending. That is be clear. Now we are only creating the model. Okay. So what we will do, this is the ground floor. We had created everything. Also the foundation level. We had created the point where we are going to be fixed that uh, this foundation. So again, now again we have to go to the first floor slab level, second floor slab level, and as well as roof. It means there is three steps we have to repeat this. So now this in this case, if I will select this node and go for the translational repeat in Y direction, it will only create column. It will not create beam. It will only create column, it will not create beam. So what we will do, we will select this beam at this level, and then we will go for the translational repeat. So it will create beam as well as column, both it will create. So what we will do, so here how can we select this beam? The for that we have to go for the beam cursor. So go to the beam and then beam cursor, and then one by one beam we have to select with the control panel. Sorry, with control keyword. So it is also taking so much time. This is not the good way. How can we select every time one by one? So what you do, there is one thing says in STAAD.Pro, if you will select this, it is automatically selecting the below of this beam. So how we will go, how we will do this? So you have to go to this view and front view. You see, and if I will select this beam by drag, it will select all the beam. Okay. All the things is available. You should know. Either you have to go one by one, it will take time, or either you have to follow the technique. So now we have to go for the translational repeat. It means again we have to go to geometry and then translational repeat. And then this time we are going for the y direction. I said the spacing between the floor to floor height is 3 meter, and this is G plus 2. So we have to go for the step 3. Link a step I need, or then just place the this model as which after this. It was looking at the start very tough. Q, it will take so much time. But when you will go uh, further, so it will very easy to construct the model. But still, yeah, when you will go for the, we had not transferred the slab. Slab is still at the ground floor level because we had not selected. So what we will do, we will select the slab. So go to select, select and plate cursor, and then simply you will drag because only at this level the slab is there, so it will select the slab on that floor. Now again go to the translational repeat geometry, then again, and we are going to the y direction, and then this is 3 meter, number of step 3. This time we will not give link step, otherwise again it will create the second column. Okay. Again, it will create the second column. Column already is there. So we will not give the link step and other things this time. Simply this. So it has created. Now I have to check. So we have to check everywhere the slab has been created. The beam slab and column, everything we had created in our line diagram model. Also the foundation is there. So we have to fix this foundation, but one by one. Now here the support is here, so geometry, after geometry the property material specification then support. So after geometry we will enter into the properties because already we had created everything related to the geometry. Okay, now we have to go to the property, and in property the beam column, and when you will click anywhere it will deselect everything. Fine. So now we have to create the dimension of beam as well as dimension of thickness of slab and as well as the yeah beam column or slab. Fine. So here the one box is there. Let me move it here. That would be better. So here when you will see here, the thing is that the thickness, edit, prismatic standard, which is that prismatic, prismatic, fine. The prismatic means when you are going to give the dimension for your beam and column, you have to select this prismatic and it will appear like that. Rectangle, in our case, rectangle, no, no, this is not. Wait for 1 minute. Oh, fine, fine. This is that. Let me check other option. Delete, dataset, standard, legacy, use table, prismatic. Fine. Prismatic, we have to click and we are going to provide usually the rectangle section for our beam and column. So in case of beam, I am assuming the width of the beam is 250 mm and depth of the beam is 350 mm. I am assuming, I am not saying it is going to be uh, past the design. At the time of design, also we will update the things. So the YD value is 350. So it is in meter, so 0.35, and ZD is the this dimension. It is the 0.25. It means 250 mm is the width and depth is the 350 of the beam. And concrete material, so you will click add, so it will appear here, but it is appearing with the different unit. Okay, be careful. You had provided in meter, but this is the glitch and I try to solve, but it is still glitch is there. So we don't know why this glitch is there. It is coming in inch. Okay. I also try, it is this problem is not in a select series, but I am facing this problem here. Okay. It is appearing in different unit, but it is entering in meter. Okay. It is appearing in inch actually. Fine. This is in inch. So after that beam, then we have to also give the dimension of column. For the simplicity, I am assuming the square column. Otherwise, it is lot of thing is there. So I am simply assuming the column size is 0.35 and also in other direction 0.35. And concrete material. So the second one is a square column. So also we have to assign this dimension to our column and beam column finish. Then after the thickness of the slab, select this thickness, click this thickness. So this box will appear. You have to give the thickness as per the code. The code is saying your thickness of the slab should be 4.5 inch. It means 117.5 something. So we are going to provide the 5-inch slab. So 5-inch slab means 125 mm. So 0.125, I am going to provide the thickness of the slab, and the thickness of the slab has been appear here in terms of plate. Okay. So now we have to assign this beam, column, and plate to our geometry. So first is our beam. So we have to just give the hello sir blue background. We have to give the blue background and then we have to go for the select option. Now we have to select all the beam. So how we will select one all the beam? It is very difficult to select one by one. So there is one option in select. You have to click the select, and here beam cursor is somewhere. It's the beam, and you have to go for here the node beam plate and something is written. In beam box, you have to click on parallel and beam parallel to X and again beam parallel to Z. It will select all the beam parallel to X and Z. Fine. And then you have to assign. Here lot of option is there. Assign to selected beam, already selected. Assign, use cursor to assign like that one by one. You have to go and assign. It is very tough. But sometimes if one beam you have to assign, use that thing. And assign to edit list. You can give the name of this member. It will also assign to that. It is very also tough. You have to find the number first, then you have to assign. But some technique is there. You have to create group and you can do that. That is the another thing. When you would be in expert level, then we can use. And assign to view, it means it will assign to all the beam. But there is a problem with the STAAD.Pro. STAAD.Pro cannot distinguish between the beam and column. They are assuming all are beam. So if you will assign to view, it will also assign to column. That is the problem. So the best way we have to select and then assign to selected beam. That would be better. Now when you will assign, it has been appear with the notation. Okay. So after that, you have to assign this column to this column member. If see, if I am saying member, I am saying beam and column member. If I am saying element, element is slab. Definition you will learn later, but this is the difference. Ki slab is element, or even staircase is also element, and the beam and column is member. Okay. So now we have to this. Select this column. So what we will do, we have to go to the select, and then we have to go to this beam. They see here beam is there. No option of column is there. Correct, na? That's why the STAAD.Pro cannot distinguish between the difference between column and beam. So we have to be specific. So we have to go to beam and then parallel to which axis? Y axis. Oh, now we have to remove the other then only otherwise. So go to the Y. So it will select all the Y. Already it is with no silly. This we have to assign now. So when we will click first click this, then go to there. Otherwise it will not assign. The parallel to y-axis and then assign to selected beam. So assign to it has been assigned. The column has been assigned to the vertical member. Fine. Now we have to assign to slab. So slab generally we can assign to view because everywhere we are going to provide the same thickness slab. So simply assign to view, it will assign or select or assign. So assign to view if I will give all the slab has been assigned. So up to that, we had also created the model. We had assigned the beam, column, or slab. We had given the material properties. Concrete we had given. Even we had given also the thickness and dimension. Everything we had given. So now here we finish. Material already we given. Material already we given. Concrete, concrete, concrete. If it is not, so we have to also change from here. But already we given. Specification, I am skipping this part specification. This is for the secondary beam or some kind of other parameter we can use here. So this I will discuss later, not now because in our case now the secondary beam is not here. Okay, now support. So we have support.
मैं कह रहा था अगर थोड़ा आपको जब भी जरूरत पड़ेगी मैं बगल में ही बैठा हूँ सर मुझे यहाँ बुला
हाँ बोलते हो बोल दो मना
हाँ वो भी अभी
ठीक 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 ओके सर now we have to assign the support. We have to fix this support. So simply we have to go to support. Now here the no support is there. So first we have to create the support. Or as per the real world design, we are assuming that our structure is fixed at every node as well as the support. Okay, real world it is not fixed, but as per the design we can assume like that. So here we can reduce lot of support is there, fixed pin, fixed but in ports, other kind of option is there. We have to go for the fixed. Fixed means all the degree of freedom has been restricted. So all the degree of freedom has been restricted. In pin, all the degree of freedom has been not restricted. Movement is allowed. So in fix, we have to just add. So this support has been created. Now assign this support. Where we have to assign this support? We have to assign this support to the bottom nodes. So we have to select this bottom node. So for that, what we will do? We have to just go to the view. We have to change the view. Otherwise, we cannot select this node. So what we will do? We have to go to the view, and then again we have to go for the front view, or also we can go for the top view, or simply we have to select this bottom node. It can select all the nodes and simply we have to assign to selected node or assign it will assign the support, correct. So up to this fix, after that loading, after that loading. So in loading, if we will up click the loading, this kind of box is appear. The first box is for the definition. In that, if you are working for wind load or seismic load or some kind of vacuum load or some other kind of non-linear or linear analysis, so we have to use this definition. Otherwise, for dead load or live load, simply load case detail. You have to click and add from here, and then this box will appear here. The dead load, live load, everything is given. So simply the dead load, and you can give name by yourself. I am giving this DL means dead load from my first day, so I am giving on the dead load, and then add it. It has been appear here. Again, the live load you have to click. Roof life is also, but later we will see the roof life and other things. Live load also we have to click and add. So also the live load appear here. So we have to close, but here nothing value is there. So dead load, just click and click on add. So it has been going with the one kind of box also. The building has their self weight like beam, column, and slab, what we had provided, that is the self weight of the structure. So self weight we have to give, and here though minus y is there, so y we have to click y, and the factor is -1, and y is the vertical. That's why we had selected this, and we have to add this. Then this has been appear with the question mark. Here is the question mark. The meaning of question mark: this load has not been assigned to our structure. We have to assign. Otherwise, the question mark would be appear always, and it will give the error when you will run the analysis. So what we will do, we have to again the what type of dead load is there. The other type of dead load is that ki brick wall load is going to be going on beam, correct? So as per 875, the I'm using if I am using the red clay brick, the unit weight of red clay brick lies between 18 to 20 kilonewton per meter cube. And I'm assuming कि our wall thickness is 9 inches, it means 230 mm. 9 inch means 230 mm. So height is already 3 meter. So we have to convert this what 230 brick work into the dead load on our beam. It is going to be brick load is going to be our on our beam. So height is 3 meter, thickness is 230 mm, it means 0.23, and the density is 20. So how much value would be there? Kilonewton meter. When you will multiply, it is nearly about 13.5 something. When you will multiply this all. Okay, the brick now this is brick wall. See here, this a partition wall is brick wall. Below this brick wall, the some beam is there. So this brick wall load will go to that beam. So how we have to calculate this brick wall load? The thickness of this brick wall and then height of this brick wall. So it will convert to kilonewton per meter. So it is coming approximately 30.9. We can also apply this. So where we have to apply member, I told the beam and column are member, so we have to apply on beam. So beam is member, so we have to apply on member. And then load, I told you it is going to be 13 point something, 13 to 14. So I am using this 13.5 and global y direction. So it will start from here and it will go up to here, this end, complete beam length. Then and also it is going coming with this question mark. Also, if any kind of dead load is there, so yeah, any kind of dead load is also there. Like flooring we are providing, plastering we are providing, like false ceiling we are providing, false ceiling. Then tiles we are providing. So a lot of thing is there. So I am assuming other kind of dead load is equal to 1 kilonewton, and I am giving the name to that superimposed dead load. Okay, what is that? In dead load, superimposed dead load. So I am simply giving the dead load and add, and then I am going to use this dead load is coming on the floor. So I am just giving the floor load, and the floor load pressure is 1 kilonewton per meter square. I am assuming the complete via this tiles, plaster, false ceiling, all combined, fire water pipe, everything 1 kilonewton per meter square. And given the range, I want from bottom to top. Also, I am providing a roof. So bottom means it is started. Y value has been started. Or if I will not give any value, it will provide everywhere. Let me check. This will be the -1, and let me check it is providing or not. So add and then simply click. No, it is only provided at this level. So we have to edit this. We have to give the range. Whatever the dimension of our structure, as per that, we have to give the range. So in x direction, it is 9 meter approximately. It is 9 meter approximately, and it is in this direction 15.24. It means 16 meter. So 9 meter, 16 meter, and height is 333 and 2. So 11, it means 15 meter in y direction. So we have to provide the value. It is 0 and then y range is I am providing 15 meter. X range also it is coming to the 9 meters and Z is also coming to the 15. So I am providing the 18. So when we will do this, it where the this kind of load dead load has been appear on the slab. The dead load 1 kilonewton per meter, and this is not with the question mark. This is not with the question mark. Careful. It means this load has been assigned. Okay. Now again go to the live load, and live load usually we are going with the 875 part 2, and from there we are picking the live load for the residential building or commercial building or balcony, veranda, kitchen, washroom. Different loads are there. But for our case, we are simply going with the 3 kilonewton per meter square. It is also given in the code residential building. Maximum load we have to consider. So live load and then add, and then again we have to go with the floor load. This is acting on the floor and the pressure I am giving -3 and range, the same range we will give. So whatever the range 18 or whatever the range, the 12, more than that it will provide everywhere. Z is also it is 20, fine. And then simply add. So the live load also it has been appear here. Clear? So only two load we are going to use Z or live because as per our fifth sem or due to time concern, we if we will enter into the wind and earthquake load, it will take a lot of time to model, apply the load also and design also. So this earthquake and wind load also we will keep for the 5 days training program. Okay, fine. So for today also, because all in case of if I will take wind load or seismic load, we have to go with the combination. And as per the table 18 IS 456 2000, I think page number 67 or 68, it is a combination, total combination is 36. So 36 combination we have to create here. But if you win dead load or live load, only one combination is there. 1.5 dead load plus 1.5 live load. Also, you have solved lot of numerical related to it as per the limit state method. Correct now? For strength design and for serviceability, simply dead load plus live load with 100% and dead load or live load with 150% for strength design. Correct? So simply I am just using that. So now self weight we have to assign. So self weight we have to assign to everywhere in beam as well as element. So simply assign to view, assign to view, assign to view. It will assign everywhere. Now this load we have to assign on beam. So in that case we have to select beam. First select this. Sorry, select this, and then we have to go to the select and then beam and then select parallel to X and then parallel to Z. It has been selected. It has been not appear. पता नहीं चल रहा है. नहीं पता चल रहा है ना. चलो रुको उसका उपाय करते हैं, कुछ हो जाएगा. Loading, then okay, then select, and then parallel to X. Now okay, then parallel to Z. Now clear. And now this background, it has been not selected. Fine. Now assign to selected beam and then assign simply. It has been applied. It has not appear. Why it did not appear? -13.5 kilonewton per meter. Fine. Okay, it's a glitch is there. Otherwise, it should be so. Maybe some scale factor is there with the scale. Let me check SCALE scale. Some scale set the scale of the load and other things. Then load, force limit, animation, structure, design result, scales, point, moment, point, pressure, distributed force. Kilonewton per meter. How this point force would be kilonewton per meter? I don't know. Okay, leave it. Next time we will discuss this. So all the load we had applied on the structure, it should appear, but I don't know why it is not appearing. Maybe a student version we are using, that's why. Because the live load and everything is coming. Ah, now it's come. It came. See, 13.5. So all the loads is appear. The dead load UDL is acting on the beam, and then it means we had prepared the model, we had assigned the material properties, we had also the load, dead load, live load we had applied to the model. Now we have to go for the combination. So combination also load case detail and then add you have to go and then here you have to create the defined combination. So combination you are using the dead load and then live load and the factor you are using 1.5 for dead load and 1.5 for live load. And here you have to write like that, then you should also understand letter and then dead load plus live load. Clear? Then add, so simply this value is appearing here. See the combination. Fine. If you are not doing combination here, also it is not necessary to you do the combination here because combination we are not using for analysis. Be careful. Combination we are using for design. And in STAAD.Pro we are not going to do the design. Design we will do in RCDC. So if you are not doing combination here, there is no problem. And be careful, we are doing combination for design, not for analysis. Careful, be careful. Okay. Analysis, separate load, separate analysis, and at the time of design, they are combining the load and they are designing the member or elements. So now finish everything. After that, loading the we have to go to this analysis folder, or we can go from here also. So it's better to go from analysis. When we are entering into the analysis, some box has been appear. You have to go to define command and simply don't disturb anything and simply add and make sure ki your no print option should be clicked and add so perform analysis has been appear here. After perform analysis, if you want something, so you can also give that command. So in that you have to here the pre-analysis command, post-analysis command. So I'm interested in something. So when you will click post-analysis command, here you can define this command and I'm interested in support reaction. So you have to select all this parameter or just click here this so one time one by one and this all together and then you have to add this. So this, sorry. Uh, support reaction. Where is support reaction? This support reaction. And then add. So this support reaction is the load list I am removing. That is not important. So simply the delete option is not there. So we have to right click one. Right click is working. Delete command. Fine. This is again coming with the question mark. It means we have to assign this things to our related position. So where we have to assign this print support reaction at the bottom. So same simply we have to go to the geometry and then we have to sorry geometry view and then front view. Then node cursor we have to select the node cursor first and then select all the nodes and then we have to assign this with assigned to selected node. So it has been assigned the clear thing. Fine. It has been assigned. Now everything finished. Now we have to go to the analysis and design and we have to run the analysis simply. So before that we have to save the model because we had not saved the model still. So we have to save the model and then find. Then we have to analyze. So run analysis. So it will run the analysis. Checking the license. Let's see. Now we have license or we don't have the license. Why it is checking so much? See, it's completely run with the zero error, zero warning, nothing is there. Okay, so you can also practice. So you can make the any model. This is a one type of sample model, but you can make any kind of model, either steel or either RCC or either combined steel or with the data and live load. And also wind and seismic later we can apply and we can also do that. So analysis finish. Analysis part is finished. The volunteers taken the attendance of session one. So it is a time of 10:44. So there is a break of 15 minutes and again session two attendance we will take. So 15-minute break is there. You can relax. Then we will go into the design. Analysis is finished. Now I have to show some kind of analysis related thing. So you have to go to the post processing. What happened? Why this gone off? Geometry. Okay. Fine. रुक जा भाई हल्ला मत कर. So here we are interested to see post processing. Where the post processing things are not coming. Post processing another thing. Physical model. Post processing. Okay, fine. We have to go to the post processing and we can see everything. Here the shear force, bending moment diagram and other thing. The reaction we can see the reaction is appearing here. The if you will select any kind of member, select go to select B. आवाज ना करे. अरे आवाज ना करे यार. अभी मैं यही हूँ. You have to select this and then go to beam result. You can see the bending moment and shear force diagram. These are the bending moment and shear force diagram. Okay, but these are not important for us. Analysis result is not important for us. Analysis result is important for us when we have to go for the lateral load analysis. Because in that case, we have to check कि our structure should not go beyond some limit in a horizontal direction. Okay, that is important. In that case, the analysis result is important. In that case, we have something is related with the drift value or a story drift we have to check or maximum drift we have to check and lot of things is there. So this is related with the earthquake. This you can check from here. This is not a big deal. It's a very simple thing. Bending moment, shear force diagram. Fine, and support reaction if you want to, you can see here, but this is okay. So I am just from here we will enter into the RCDC directly from here, or again otherwise we can separately open RCDC and we can recall this model. One thing also there key when we are saving this stat profile, it is creating the .std. Top it. Look at here. It will save by .std file. Okay. When we will recall in other software, we have to also call this .std file import. Then we have to go for the design. So we had already saved and our name is RCC G+2 building a structure. Let me check if I am closing this. So where is our model? We had saved in one model, the stat file and stat file. This model is there. RCC G+2 building which we had created now. Okay, already in that folder it has been saved. So there is a 15-minute break, 10 minute, not 15 minute by 11. Volunteers by 11. All the students should again came back to here and make relax. Then we will start the design. Okay, design of slab. You can go. No, you can go. हाँ जाओ 10 मिनट का ब्रेक है जाओ पानी पियो आओ रिलैक्स हो जाओ हाथ पाँव हिला लो बट द सेकेंड सेशन अटेंडेंस वी विल take from 11 a.m. onwards. कितने लोगों का अटेंडेंस हुआ फिफ्थ सेम वाले कहाँ है सारे हाउ मेनी स्टूडेंट फ्रॉम फिफ्थ सेम हाँ यही ही है फिफ्थ सेम में क्यों क्यों नहीं आए भाग गए पता चला आज ये इवेंट होना है, भाग गए अब मैं सिखाऊंगा ही नहीं आप लोगों को क्लास में हो गया मिनी प्रोजेक्ट खत्म आओ गया, आप लोग अलग से पढ़ा दूंगा। हो गया, ऑनलाइन पढ़ा दूंगा, हो गया। क्या करना है? ये तो गलती हो गया ना, क्लास में पढ़ाया भाग गए सारे। ये कहाँ है, कितने बच्चे हैं? कितने हैं, कितने हैं लिस्ट में देखो। 30 बच्चे होंगे और 60 बच्चे हैं। अच्छा, क्लास ही नहीं आते। अरे ये बना भी लिया, ये तो बना, वेरी इंटेल, वो भी बना लिया है, इंटेलिजेंट है हमारे सारे। ये भी बना लिया, कितना, ये भी बना लिया, क्या बात है यार, ये भी बना लिया। Oh, now I have to stop the pause the recording. When I will, please remind me at 11, 11 बजे मुझे याद दिलाना कि pause को हटा। Recording again continue. Now we had finished the analysis with the help of this STAAD.Pro. Now we have to use this RCDC. So either you have to double click on RCDC and right click and run as administrator. So right click and run as administrator. So it will take little bit time to configure the license and other thing, and then it will appear with one window. Please don't talk. Please. So now you can see here after opening this RCDC, we are here to look this screen. Here it is written RCDC or STAAD.Pro Advanced. It is my suggestion to don't touch any or don't disturb any setting. Simply click accept. That would be better for next processing. Next step. Sorry. Then when you will click, it will appear like that, a window. So here, if you had already created some RCDC work, you can go from here and you can create, or otherwise we have to create, click on new, because we are here to create new things. Okay. Again, you have to give the name of the project, client, engineer. They are optional. Either you have to give or not give. It is not going to affect anything. But for record purpose, you can give our RCC G plus 2, and then what is that? Buildings. Fine. This is the project name is there. And then in place of खांसी क्यों हो रही है? Client, if you have any client like that, you have to give the name of client XYZ. I am giving the XYZ, the name of the client, and engineer's name. So we are the engineers. So I am writing here self, and here you can select the code. The 6 country code is given: Indian standard to British, and then American, then European nation, and then Egyptian not. It's a NSCP or AS. I don't know about this two. So we will check this two from belongs to which country. From here also you can select the code. Here two code is there, 456 and 13920, and 456 is with the edition year 2000, and 13920 is the edition with 1993 and 2016. So 1998, at when before 1993, when the lot of earthquake came in our country, so the Bureau of Indian Standard has decided that we have to go for some kind of uh, special provision provide in the building. So our building should disperse the energy at the time of earthquake. So they had prepared one draft 13920 in 1993. It's related with the ductile detailing. So ductile detailing means at the location of beam column junction, we have to take care special thing where when we are providing the reinforcements of main bar as well as the stirrups, we have to take care
we have to provide as per the 13920 ductile detailing. Also, the we know the length of the one bar is 12 meter. So after that, if any kind of lap is there, so also at the location of lap we have to be more careful. कपलिंग भी कर सकते हैं, कपलिंग है बेरिंग ने बेल्डिंग भी करते हैं. We can also give the lap, and also where here if we are giving some kind of curtailment in place of bent up, so where we have to give the curtailment, we have to be take care of that. As all these details are given in the 13920. Also, how the stirrups hook at the end, it would be 90 degree or 135 degree. Also, all the details has been given in 13920. It is related with the earthquake ductile detailing. It means ductile detailing, it means lateral forces hitting our structure, but our case is dead load plus live load. So maybe in this we will not use the ductile detailing, we will go for the simple design. So after that, analysis data. Here, analyze data, select, he is saying select STAAD.Pro std file, ETAP MDB file, or ETAP EDB file, or RAM connection RSS file. You can select. He can read up to that much file. STD file means STAAD.Pro file. MDB file means ETAP Microsoft Office Access database file. ETAP EDB file, ETAP database file, and RAM connection RSS file. He can read up to that much file. So you have to select your file, STD file. You have to click here. Then you have to go event day, and then you have to go to this stat file, and our model is RCC G+2 building we had created now. So you can select from here and then click on OK. So after clicking OK, earlier it was disappear. You cannot touch this boxes, but now this is appearing and you can touch the boxes. Here you can design pile cap, here you can design footing, here you can design column and shear wall, here you can design beam, and here we can design slab, and also you can design water tank structure. This much things you can design in RCDC. So we will start from slab. So when we will click slab, it is showing all the level: -2 foundation, 0 ground level, then first floor slab level, second floor slab level, and roof. So if you are interested to our slab is at 0 level, 3 meters, 6 and 9. All this 3 -2 we had not provided any slab. So I am just, if you are interested to design this level slab, you have to click and go for the create project. Again we have to design for this level slab. Again we have to create, and we have to design. So I am selecting this 3 meter for a for showing here the design of this slab. So if I am selecting 3 meter, just change the name, that would be better. In place of that, you have to write 3 meter, RCC G+2 3 meter, and we are interested in slab, so you have to write the slab. That would be better. Fine. So there should be some difference what you are doing or what you are not doing. 3 meter slab we are interested to design. RCDC is designing the beam, column, uh, isolated footing, and pile cap. Also the slab. But in case of RCDC is also analyzing the slab. Okay, whatever we have done in STAAD.Pro, he will again do the analysis. So we have to again give the load here when we have to analyze this slab or design. I will show you. It is also asking for the load. So now after clicking all this, you have to just click on create project. The next window will appear. Create project. Next window will appear. It is sign in required because maybe license. So now wait, sign in done, fine. So now it is doing the internal processing. After internal processing, the see how much beautiful user interface, how much aesthetic user interface. Correct, no? This much diagram we prepare in STAAD.Pro, but here see how much the beam location is there, the slab mark is there, everything is there. Directly you can give this to the client. Okay, this is slab, this is beam, this is column. Even the number is also given, which is C1, which is C2, which is C3, everything is given with dimension. So this you can directly give to the client. How you can give to the client? You have to save this. How we can save this? You just click this, it will save. When you will click, it will save the things. So you have to go to this event day. I had already created one folder. You can also create the folder of RCDC. In RCDC, this is slab. So I have to go to slab and give the file name. What is slab layout? I am giving the name of slab layout. So it will save. You can directly open the AutoCAD, print from there, arrange in report and give to the client. That is the benefit. Okay, all the time. In spite of that, here lot of thing is there. It is the first row, the name is there. Then after second to last, the details of the things is there. The slab mark first is number 1 to 9. 9 slab is there. You can see from 1 to 9 the slab is there. And then after the second is the slab mark. When you will click S1, it will become red. बात ना करे यार, कौन बात का है? वॉलंटियर क्यों? हमिंग साउंड क्यों आ रही है? Then when you will click S2, it will become S2. So like that, 9 slab is there. This is LX and LY. As per the IS 456, your LX is the shorter span and your LY is the longer span. If this is the span, this is LY or this is LX. If this is the our slab S1, so in case of S1, this is LY or this is LX. In case of this S5, this is our LY or this is our LX. The longer side would be LY or shorter side would be LX. And also our span type two way or one way. So here all are two way and whatever the slab is here it is one way. And also we are not going to design this slab. We are going to provide staircase here because in our original drawing a staircase is at this location. So we will provide the staircase at this location. So next step is there panel type. When we had designed in as per IS 456, when we are designing the continuous end or fixed slab, there is something panels is there ki one shortage is discontinuous interior panel or one long edge is discontinuous. All the things are there. Okay. If something is not matching with the diagram, you have to change also. That option is there. You have to select that. Then live load we had taken. Now I told ki RCDC is also analyzing the structure. So that's why he is asking for the load. Self weight already assigned. There is no need to assign self weight again. Self weight already assigned. So live load we have to assign. So live load we had provided in STAAD.Pro 3 kilonewton. So we will provide 3 kilonewton and without any sign. Without any sign. Here no meaning of sign. Without any sign we will provide. And what is imposed load? Other than live load, all are imposed load for RCDC. So what the load we had provided on slab? 1 kilonewton we had provided. The other load on slab like completely floor finish and then कौन बात कर रहा है? बात क्यों कर रहे हो? डिस्टर्ब कर रहे हो ना बाकी मुझे भी डिस्टर्बेंस हो रहा है हविंग साउंड आ रहा है कान में यार imposed load we had provided 1 kilonewton or if you want to see you can check here also in STAAD.Pro what we had provided. No, that is not a big deal. So when we have to go for this, just wait, we will open this recording going on, no? इंटरनल प्रोसेसिंग टू चेक द लाइसेंस। क्या हो गया, कर ले भाई। क्या हो गया, नहीं करेगा चेक? हाँ, यही है ना, RCC G+2। See, in loading, if I am going in loading, so in loading you can see the dead load what we had provided here, that is be edit. If I am going to -1, it means other than live load. We had given this value 1. So also you cannot leave this space blank, and also it is not taking the value 0.5. At least you have to provide 1. I think 0.5 it is taking. Let me check. 0.5. It is taking, not an issue. So one we had provided. Now thickness of the slab, I am giving 125 mm to all things. Other other details is also there, but right now I will not discuss. Otherwise, it will take lot of time. Already, if you want to know this thing in detail, in my channel everything is given. You can go and you can check from there. So now you have to provide this load to all the slab. So you have to input, give the details one by one, or simply copy and then select all the boxes and Control V. It will automatically paste to fill all the boxes. Okay. So this is the simple thing. So this whatever the appear here design input, we had fill all the data. Now we have to go to the setting and design parameter we have to put. So usually we are doing the slab design with the bent up bar, not with the curtailment rebar. We are providing with the bent up bar. And this parameter span to depth ratio we are taking from IS 456 24.1, because we had selected the हम ऐसे ये लोग करते हैं जैसे हम कभी स्टूडेंट रहे ही नहीं है, हमको बुझेबे नहीं करेगा कि ऐसे किया तो उसका मतलब क्या है, ऐसे किया तो उसका मतलब क्या है। काहे जी, हमको नहीं समझता है कि अगर कोई ऐसे किया तो उसका मतलब क्या, वो बतियाने जा रहा है, देखो तो वो समझ नहीं। कोई इग्नोर करे टीचर को तो उसका मतलब क्या है। हाँ जी, क्या पढ़ा रहा हूँ मैं, आप ही से पूछ रहा। हाँ, उठिए 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 उठिए, क्या पढ़ा रहा हूँ। हाँ, आप ही से उठिए उठिए, बताइए क्या पढ़ा रहा हूँ। RCDC में क्या, स्लैब में क्या, वो तो हो गया, वो तो पीछे रह गया। डिजाइन तो अभी आगे। हाँ, क्या अभी क्या, तो थोड़ा ध्यान दे दीजिए। क्या बिगड़ जाएगा, कुछ बिगड़ जाएगा, तो बैठ जाइए। हाँ so this parameter it is taking from IS 456 24.1 automatically, because we had selected the Indian code. Here you have to select the grade. So M20 I am selecting for this concrete grade. M20 means 1 is to 1.5 is to 3. 1 is cement. Cement means binding material, and then 1.5 is fine aggregate. Fine aggregate means our filler material, and then 3 is our coarse material. Coarse aggregate means strength material. Correct now? So M20, and then steel grade also we are selecting. So 4110 out from the market, 415 also out from the market, up to 460 is also not Indian. It is also out from the market. These three are available in the market. So I am going with this FE 500. Okay, and FE 500 also three category, two category or three category is there. It is given in IS 1786 2008. It is normal, it is ductile, or it is more ductile. Three type of category is there. So we will discuss that thing later in 1786. There in board the one code is written there. Mechanical properties of in board, right side. That board, right, complete right, near to door, near to door. Bottom side one code is written IS 1786 2008 mechanical properties of steel. In that you will find the mechanical properties of steel. From there the three categories there. Cover in slab in normal condition we are providing the 20 and thickness I am keeping the slab thickness is minimum thickness 100 Okay. So now here with the help of rebar, usually we are doing the design with the help of spacing. You cannot do otherwise you will confuse. And prefer bar I am going with the 10 or 8 also you can provide for the distribution still. And here the bent up location for the bottom end support. Bottom end support means this support is and at the location bottom end support L by 6, then bottom continuous support this he is discussing about this, so L by 4, and top continuous support to top at this location top continuous support, so we have to provide the L by 4 for the bent up bar where we have to provide the Bentaba. This reinforcement you can select from this boxes, but for slab it is better 10 we had prepared, so there is no need to go for the 8, and that 2 is enough for the slab, because we know कि in slab there is no so much demand of steel of bigger dia. So 10 and 12 it is more than enough. And after that, the minimum spacing means slab to slab distance. Center to center distance between the reinforcement in X or shorter direction and in as well as in longer direction. So here I am saying कि minimum spacing is 100 or maximum spacing I am going with the 8 inch is enough. So 200 is okay. Minimum spacing 4 or round up I am keeping this with 25. Usually I am doing 25 and it is giving the good output, correlated good output, so that's why I'm using this 25. So you can also go with this rebar mark manager. Here the main bar means where the tension is coming and you are providing the shield, that is the main bar. The meaning of this main bar is that. So rebar or rebar dia, whatever detail you will provide here, look less here, your detailing would be good. So we know already कि first thing is related with the diameter of the bar, so we will delete this. We also note कि this distance center to center, we can also delete this. We no need. So our detailing would be more. By this we can understand 10 bar dia at the rate 120 center to center. So no need to write in full detail. So simply okay main bar you can. This is only the rebar mark manager. Fine. Then okay. Agar other things is also there crack with setting, but I am not touching this part later. Okay, because this is another segment. Or don't touch this thing, otherwise all panels are non-continuous, it will convert. Don't ever never touch this thing, this option. Then go for design and simply auto design. It will design the slab. So it has designed the slab with thickness 125. If I will say slab 1, concrete grade M20, steel grade this. Bottom in shorter direction 10 bar, 200 center to center. Bottom LY is this, bottom continuous is this, and then top LX int support is this, and top LY int support is this, int not continuous, and then top LY int and distribution is still. Distribution is still also actually there is no actually some diagram, then I have to show one diagram, then it will be better. Wait for that. Slab slab अरे ये क्या हो गया ये क्या इसको क्या हुआ भाई स्लैब ये नहीं आ रहा कुछ गड़बड़ हो गया लग रहा है कहाँ हो गया जी इसको? हाँ आ गया. You can see in this diagram, this is very good diagram, then you can see in this diagram, that would be better. बड़ा धीरे चल रहा है नेट. आप लोग कभी साइट पे गए हो? कभी साइट वाइट पे नहीं गए? तो जाओ, जाके देखो. एनी इंग्लिश स्पीकिंग? एनी इंग्लिश स्पीकिंग कोई है भैया अंग्रेजी बोलने वाला का? हाँ हाँ, वन वन. Is it visible? Not visible. That is the problem. You can look at here. This bar is coming from one direction, shorter or longer direction, and then after coming to this region of point of contraflexure, or you can say L by 3, L by 4, or whatever the thing given in the code L by 6, it bent because the from point of contraflexure the tension has been gone from bottom to top. So this bend, and next alternate bar is going up to the end, but it is not necessary. You can bend all bar, but code is saying you have to bend alternate bar. Okay, and when you are bending the alternate bar, and one bar also going to at the last, you have to provide extra top on the. You have to provide this extra top like that. Ki here you it's gone. It's this bar, so you have to provide the extra top. Again you have to provide this bar like that. अबे आ का ही नहीं रहा ये. इसको क्या हुआ? नहीं आ रहा है. We have to provide extra top like that here, then here, then here. We have to provide the extra top, so it should not going to be fell against the bending. It's not visible here. What can I do? And also the pen is not working. Leave it down, close toolbar, and now pick. क्यों नहीं आ रहा जी? ये आ ही नहीं रहा. क्यों नहीं आ रहा? चलो नहीं आ रहा हो. चलो. So this bent up bar concept is this, and another direction also you have to provide this bar we are providing on the top to hold the this direction main bar, and that's why this is the distribution steel. So distribution steel is only to holding the main bar. So we can provide with the minimum dia of the bar 8 mm we can provide. 8 mm just holding. They are not contributing to overcome any kind of bending or compression forces or other things. So that's why we can go with the 8 mm. If 6 mm is also available, we can provide with the 6 mm also. So here also, here the things after designing this is coming, but this is not important for us. What we will go, what we will do the things. We have to go with the report and generate the text schedule. When we will generate the text schedule, it is asking, do you want to group the similar slab? It means similar reinforcement is in two different slab. It will combine that slab. That is good for us to read on the site. So we have to group this, and we can see here it has been made the table like that. The slab number S1, S2, S3, S4, S5, and the thickness is there, type 2, and bottom reinforcement is 10 mm at 200 mm center to center, short span and long span, and when it is going to be bent up, with that key also that short span is the 10 into 200, and then again it is 10 into 200 because we had preferred with the 10 mm bar. Distribution still you can change. You can save and go to AutoCAD and you can change this. You can just simply write here distribution still 8, and it my suggestion when you are doing this all the blank space you can fill, and you should write one line here where it is, where this reinforcement is not required, there is no need to provide. This is the best way to just provide this. Or otherwise you have to write like that, there is only two type of reinforcement: bottom reinforcement or top reinforcement. Leave this short or long span, or short span, long span, or continuous, or what. This top reinforcement also leave, or this the bottom also leave. Reinforcement short or long, or you have to just write here and write one line here: alternate bar should be bent up. Alternate bar should be bent up, and where we are bent upping the things, we have to provide the extra top reinforcement. Okay, so some kind of modification also you have to do. We can not rely 100% on software. Okay, so for the execution on site, only this table is enough to place the reinforcement as per drawing in the real ground. Okay, only this table is enough. There is no need of extra kind of table or extra kind of diagram is required for the reinforcement placement in case of slab. Okay, only this table is enough. But lot of option is here available. So you can also save this. So if I will go, please save the project here. We have not saved the project, so we will save the project first. So we will save the project in, wait, file name RCDC na slab na. We are going with the slab, so we will give the name of slab simply, and then we have to save this diagram and slab layout, then slab, what is it, slab schedule, slab text text schedule. We can open in AutoCAD and we can edit this value, okay, as per our requirement. After that, also in report general arrangement plan, this is nothing much. This is simply the slab beam location, thickness, and the beam, what beam has been used. Also, we can save this by general arrangement plan, so you can do it later. Again, in report, in plant detailing, also we can go like that in plant detailing. Ki whatever the reinforcement is there, it is complete detail of reinforcement in X and Y, shorter span and longer span, and the nomenclature is also given. Some table maybe not table is so some, okay, 10 mm bar, we are, it's a given written here already, 10 mm bar at 200 mm, center to center spacing, and how much where it is going to be bent, and this like that ki after this support, up to what extent we have to extend this bar on continuous support, and when alternate bar bent up, this bar is bent up and gone to top, so this bar is not bent up in this side. So one bar bent up this side, so alternate bar will be bent up on this side. That would be careful. This is the again important thing. So like that, all the details is there. But for slab, this much diagram is not necessary. Otherwise, client will confuse. Okay, client will say, like, what is this? So simply give the text schedule. That is more than enough. I am also giving the only text schedule. That is not a big deal. So you can go with that. And again, staircase. That is the very good thing of slab designing in RCDC. Staircase section, it is designing very nicely. So we can also do by that. For that, we have to just go to our center line plan. This part is for the placement of reinforcement. We are going to provide the mid landing here, entering from this side, and this is the flight of, this is the space where we are providing the waste slab or flight of the staircase. Fine. So this location we will provide the staircase. So what will be the value of that? So total our staircase boundary is 5187, and then we will subtract 900 from this and 1730 from this. So this value will come, calculator, and then open. Now 5187 minus 900 landing, and then bottom landing minus 1730. It is coming 255. In this space, we have to provide the stair. It means the space which is this, from this boundary, we have to provide the stair. Okay. So we know कि floor to floor height is 3 meter. So landing would be 1.5 meter from ground floor or 1.5 meter from the above floor, below the above floor. So half landing we have, half stair we will prepare, then half a stair next uh, half a stair, or we can prepare one time, and second time also we can prepare the half a stair. And in AutoCAD we can merge this two segment, so it will appear like a one segment of staircase. So now I am preparing this half. We are entering from here. This space distance is given. This is 900, and this is also we are going to provide the beam at the landing at this location, beam at the landing of uh, bottom landing at this location. It means end, and also downside, not upside. We can provide lot of thing option is there, but we are providing the downside. Here it's written. So beam depth, whatever we had provided in AutoCAD, 250, and depth was 350. The top landing was also 250, and this is 350. Then end of the slab and end of the slab, bottom landing and top landing, and down a stand. So number of rise actually 150, and we are giving the rise for residential building 150 mm. And so we know ki rise would be always greater than 1 by trade. If trade is 9, our rise would be 11. If trade is 9, our rise would be 10. Correct na? Staircase. Like that a staircase is there. Arey, why it not working? Not working. Not working. Leave it. So staircase, in a staircase always the rise would be one more than trade. So we are providing a rise, our 1500 divided, we are going to provide 10 rise. So one rise is 150. So number of rise is 10. So again the trade is 4, and this is span. Span is how much we calculated already. 2557. Span is 2557 mm, and the height is 1500. Half the stair we are going to prepare. Landing span, bottom landing span. It was given in the diagram. It is approximately 1730. So we will put here 1730, and then top is 900. And which slab S9 we are interested to convert into the stair. So it has been created the stair. Okay. This is simple, very simple. Is created this. Otherwise, we have to design lot of thing, and then see the presentation. How much good presentation is there? The everything is there. The bar length, what bar we had used, the dimension, the thickness, the flight, and the rise and trade, and the how we can uh, place the reinforcement at the landing and near to landing and at the bottom landing. This cross type of reinforcement, bottom top reinforcement going to bottom, and bottom reinforcement going to top. We should take care of this thing, otherwise your stair will be fall down. Also you can save this staircase, then go to save stair. So stair design you can save by this, very simple. And also give this directly in the report. Correct na? Directly we can give in the report. Half is this, half again you have to draw, and if you want to merge, you can merge in AutoCAD. Okay. So next time half, so our bottom landing would be this, and top landing would be this part. So you can merge in AutoCAD next time. So after report, then slab section also you can generate. In plant detailing we had generated. Slab section also we had generated like that. Ki I want to see the reinforcement of any slab. Let me just make it big. If you want to interested to see the reinforcement of any slab like that, for S4 and S5. If I am interested to see the section of reinforcement this, so what we will do, go to and slab section. Then here number of slab is 2, so number of slab put 2. Mark I am giving as the slab mark, so S4 S5. So S4 S5 I am giving S5, fine. Then the slab you have to select S4, and then LX LY it is selecting automatically the shorter span this side and longer span this side. Then left support type is ind support, and left support mark is B15. So we will give the B15 beam number. The beam is 250, depth is 350 mm, and then it is continuous. Right support mark B23, sorry, B23, and then this is 250 again, whatever you had provided the thickness, the dimension of the cross section of the beam. And then again here you have to select S4, then S5, like that also. You have here you cannot edit, because this value would be equal to this value, and internally it is filling this place. Okay, correct now. Continuous, this is the right support continuous, and this is the left support for this, so this is internally filling this space, so you cannot edit this. So here again you have to write mark B26, then after 250, and then it is 350, and then simply draw, so it will give you the slab section. Clear? This is giving the slab section, and here it is very clear, no confusion, where you have to give bent up, how much distribution is still spacing, distribution still is this, and then up to what end we have to extend the bar of bent up bar in beam. And here also you can see the top reinforcement, extra top reinforcement, when we are providing up to how much length we have to provide. Ly 3 we had selected, or Ly 4 up to this length we are providing. On site, be careful, see here, this length is 955, this length is 760. When you will say to the mason or labor कि you have to provide like that, they will be confused, or they will make the mistake. Because if you will say 760 this side, 955 this side, it is very confusing. So take the greater value among all the things, and then say कि you have to provide this much length. Otherwise they will make the wrong decision, they will provide wrongly. It is the good practice कि you have to take the longer side. So 955 is longer, to either you have to go from here to here 955, and this side to this side also 955. That would be better. And bottom side also like 640, so this should be 640. Okay, be careful. Otherwise, definitely they will make the mistake. Okay, so like that you have to do, or simply L/3 or L/4. They are not understanding this thing. Okay, so simply like that you have to provide the. This is very much clear. There is no confusion in this. Alternate bar bent up. See, alternate bar bent up, no problem. And where we are doing the bent up bar, we have to provide the extra top. Simple. Clear? So this, and again, if you want to see another section, so you can also generate in this, or in other window also you can generate. So like that, if I am interested to see the S8, S8 simply, so report and then go for the staircase section. Sorry, बातें नहीं भाई, क्या हो गया, slab section, and then it is S8, so you have to write here S. न मानिएगा, मार्क्स काट लूंगा मैं. S8, now LXLY it is taking, the S8 is how much? Beam B20, left support mark B20, and then B is 250, and then it is 350, and end support right mark is B24, then it is 250, then it is 350. Now it is that key, if you want to see this diagram with this, or if you want to see in new, that both option is there. If you will click this option, this diagram will appear here. Okay, so you can just click here, it will appear here. Okay, so be careful what you are doing, or it's better, but that much detail is not required in case of slab. If any kind of confusion is with you, you have to generate for yourself, see the reinforcement, make the table, give the site engineer, they can place the reinforcement on site. In case of slab, beam it is required, column only cross section is required, nothing much is required. Foundation also, it is top view is enough for that. Top view, and you can play, say that key longer side this reinforcement, shorter side this reinforcement, spacing is this. So that is more than enough. So reporting is different thing. For understanding, it is different thing. Okay. So after that, also in report, you can see the complete project setting, what the setting you have done. So why it not come? All the setting, yeah, like that key span to depth ratio, bottom in support, bottom continuous support, where you have to bent up bar, what is the dimension of the bar, then what grade of material, concrete and steel you selected, everything is written here. You can check or which code you had follow, what the parameter you left. Also you can go for the design summary. This is a summary, whatever given written in table, it is written in the small segment in box. Fine. Also in report you can go for the design calculation. This is complete design calculation. I am not selecting all, just one slab I am selecting S3. So it will give you the complete design calculation what you are doing in your classroom. Okay. The instructor is writing on board and you are doing the design of beam, design of slab. This is the complete thing. Okay. The best solution. You will not get this kind of solution anywhere. This is the best solution to learn for the learning point of view. Okay. And also in report bill of quantity you can generate if you know the value of your grade of concrete, like that 65, maybe 6500 per meter cube, and fe का rate है अभी maybe अधिक हो गया 75, and plan area you have to give, so 15 one side and 9 one other side, it means 135 meter square. And currency, that shuttering cost also running meter, it is in running meter, so maybe 650. You can check in your area running meter, ask the vendor, they will say, and you just calculate, it will generate the bill of quantity approx data you can get. How much money it is demanding? 2065,613. In case of design of one floor only, we had selected only one floor, 3 meter. So 0 meter, 3 meter, 6 meter, 9 meter, then roof. So 0 meter also slab is there, 3 meter first floor plus floor slab level, then 6 meter second floor slab level, 9 meter roof. So total 4. So 4 means multiply this with 4. Approximately it is coming 10 lakh, 11 lakh. 11 lakh. Then labor cost is not included in this. Labor cost vary place to place. It vary from 35 or somewhere 25% of the total material or a cost, and then after also it is reaching up to the 50%. Also 10% wastage you said include, 10% wastage. After that, whatever the value is coming, 10% wastage. So 11 lakh, and then after 50% increase, it's approximately 16.5 lakh, and 10% wastage 2 lakh more. Approximately 20 lakh. 20 lakh for 4 floor. So one floor, it is approximately 4 to 5 lakh. And it is okay. 1300 square feet. 1400 square, 135 into 9. How much this? 3.28, 3.828, 1350 square feet. So fine, 1350 square feet. It will take the money of 3.5 to 4 lakh. It will take. Okay. So this, by this way you can understand. Okay, if I am going to construct a 1000 square feet plot G+3 structure, so someone will ask is how much money is going to spend. So you can roughly calculate. And when you will calculate na, so someone will say, yeah, he knows something. Otherwise, if someone is asking, I'm going to construct one building, and he will ask you, one of the client is asking, and you are still silent, there is no meaning. And civil engineer always face this kind of problem with the relatives. When the we take civil engineering in the first year, our relatives thought of like that, ki we are civil engineer, they are still asking ki, can you prepare my building, can you do the drawing for me, and when we are seeing the that relative, next time we are running away from that location. It is happening with everyone. I also face this problem. Correct na? Ah. Fine. So this by this way, and also you can go with the bar bending schedule. This complete bar bending setting is there. The factor LD with that, and then again the bar tag manager. Also the bottom and top bar the marking is there, and then read the bar bending schedule. The this is the development length as per the Indian code for FE 500. He calculated, and this is 15. This you have to make the 25 meter. Now start with the one. The length of the one rod is 12 meter, and don't disturb other parameter and generate. So it will give you the bar bending schedule. Bar bending schedule, how we are going to place our reinforcement. Okay, like that, if any reinforcement is there, a B3 is there, bar mark B3, B9, yeah, B3 is there. So if we are going to place the B3, B means bottom bar, or how we are providing the bottom bar. So B3 is this bar mark B3. So A distance is this. After A, it is going inside that bottom. Then after bottom, it is the bent up, and then this is the E part. So cutting length is total length 4175. A part is 100 mm. B part from here to here 2350. C part is 125. D part is D. Why D is D 75? Where is D? Okay, okay. D is this from here to this downside. It is not going up to the top. Fine. D is 75 and E is our for this B3. E is our 1723 and R is also there. R is the radius of the circle at every bend. If it is bending here, definitely it is making one circle, and the radius of that circle is R. Okay, here. That is not so much important, but somewhere when you are going to the big project, all details is required. Okay, so for that you should know each and everything. Bar bending schedule and everything is there. So now the slab design is almost finished. You can save each and everything by just clicking this. It will save in AutoCAD, and from in AutoCAD also you can modify as per your requirement. Modify means not change the design. You cannot change the design. You can change the appearance to understand, to make them easy to understand by the site engineer. Okay, so slab design is over. So after slab we will try to also finish by beam in just 20 minutes, so that would be better. After that we will start the column and footing after the lunch. Okay, so now I'm going to slab design, so I'm just closing this. This also closed. Now I'm entering into the beam design. So again we have to this close this. We have to start this RCDC with right clicking. Now first we have to close this, otherwise it will not read the data. So now this close also. Now right click and run as administrator, and then yes. The recording is going on. All the recording you will get available. पानी कहाँ गई यार? ये देना बेटा, वो बोतल दे देना पानी वाली. चलो किया जाए, खुल गया होगा ना. Now RCDC, when don't disturb anything and simply accept, and then give the project name. Now it is beam, so I am simply giving the beam. Also I will go with the 3 meter, because also it is saying for different level different beam is there. Client XYZ, so client XYZ, and I am the engineer, so self, and code the same code IS 456 2000 and 13920 2016. Again we have to select the stat file from here. So we have to go to event day, then a stat file, then this is our file, and then okay. So now in this case, the go for the beam design, and beam also I am doing at the 3 meter, and create the project, and then create the project. So it will create the project again. So again you have to design another level beam. You have to again create another level things. In case of slab as well as in case of beam. Sign in is asking. So where is the sign in? मजा आ रहा है जी? हाँ, मजा नहीं आ रहा है? अरे बुझा रहा है कि नहीं बुझा रहा है? नहीं बुझा रहा है? कहेगा ये क्या बोलने लगते हैं सर बीच बीच में? अंग्रेजी बोलते बोलते भुला जाते हैं। मजा आ रहा है? तो वैसे ही बात है। अब इसको क्या हो गया? It is doing the internal processing, and then you can see here the beam and column marking is here. We have to design the beam. प्लीज बात ना करें, जल्दी खत्म करते हैं। आप भी जाओ लंच करें, मैं भी थोड़ा खा लूँ, सुबह से केवल एक सेव खा के आया हूँ। ठीक है, उतना सुबह कहाँ से खाना खाऊंगा? आइए आइए। अरे यार हिंदी बोला तो बुझाया ही नहीं। मोहन व्रत है आज। चलो आ देखो। Now here the beam is here the thing, the design input, design grouping, and beam continuum is given like that कि if I am selecting here, please look at here, please बात ना करें, 20 मिनट रुक जाए, खत्म कर लूँ मैं। ये आपको दिया हुआ है B1 is this. Here you can see if I will select this, it will make this cyan color. Here this cyan color, and the continuity is the red color. Other no any indication is there. So if I am selecting this is column 1, then beam 1, this is the continuum, then C2, then B2, and then C3. It is showing like that. And design beam grouping means also the same thing. Group 1, this is made the group of B1 and B2. If I will click that single beam, if I will click that B4, so it is making the beam 4, beam 5, beam 6. It is the making the group of this. Okay, like that all the group, total 11 group is there. Someone in this direction and someone in this direction. If I will click this is in this direction. One thing I forgot in the time of designing of slab as well as the designing of beam. The you had seen in RCDC there is no coordinate axis given. Nowhere the coordinate axis is given. Correct? So what is the coordinate axis he is following? That is the main thing. He is following the coordinate axis. If I am calling the file from stat, so whatever the coordinate axis is there, it is following same coordinate axis. It means this is x, this is z, and this is y. If I will call from ETAP, whatever the coordinate axis is there, it will follow the same coordinate axis. So you will say, what is the important? Is it important? Yes, it is important when you will go for the earthquake load and as well as the wind load. Then at the time of that, it is important. Okay, otherwise you will be confused. Fine. Now here the beam is there, the length, breadth, and depth. All the things is given beam. This is the number which is given in STAAD.Pro. STAAD.Pro number is this. Okay, STAAD.Pro beam at 3 meter. If here B1, so what is the number there? 75. Okay, that is this thing. The depth of the flange, if you are going for the T beam, then you have to provide depth of flange. Here we are not interested to provide the T beam. Here we are interested to design as a rectangle beam, and at the time of monolithic casting, it will automatic T beam. So we are not interested in depth of flange. And top and bottom, leave it that. This is also related with the sunk and the raised beam, so leave it that. So no need to fill any data if you are interested for the rectangular beam. So directly go to the setting, general, and reinforcement, we have to click this details box has been appear. So ignore torsion if it is less than 0.1 kilonewton per meter square. So if torsion is there and it is less than this, you have to बात ना करे भाई, रुक जाए 10 मिनट, फिर हम भी बात करेंगे आपके साथ। कह रहे हैं भांगड़ा खेलेंगे हम लोग, क्या दिक्कत है? हाँ, तो usually here no earthquake load, and also there is no some kind of eccentricity, very symmetric kind of plan, so torsion will not come in the building. Okay, so we will also ignore the torsion. We are not interested in ductile design because here we are not going for the earthquake load or other kind of wind load which is dynamic in nature. So we will also leave flange beam, we are not providing. So this thing we will see, but in advanced way we will see, otherwise it will take a lot of time. Also we can design the beam as a slab. Also we have to consider bending as well as axial force, so we can also design the beam as a slab. So that's why I am saying horizontal member, it doesn't mean it is beam, because it can be also designed for a axial force. If we will design as a axial force, it convert to compression member. So horizontal doesn't mean beam, but for okay, for understanding, horizontal is beam and vertical is our don't disturb this best fit. I disturbed lot of time, but it is giving some confusing thing. So don't disturb this thing. And this percentage steel we are provided from the IS 456, and this is the value of tensile steel. When you will calculate for FE 415, what is the formula? Anyone remember that formula? uh, 0.85 something is like that, right? Let me check that. Code IS 456. Page number, I think approximately 49. Oh, yeah. This, acha, this is SARE. Where is the, this one, minimum reinforcement. AS upon BD 0.85 upon FY. Calculator, where is the calculator? Calculator. Just calculate 0.85 into 500. How much? How much this? 0.85 upon 500 ना, अरे यार क्या कर रहा है? 0.85 divided by 500, this into our 100, it converted into the percent. 0.17%. So where we have to put this value? Minimum value is 0.17. It's coming. Okay, correct now, the minimum value percentage steel from code we have to put. So 0.17 we have to put. The maximum value also it's given in the code. Let's check. Minimum area of tensile reinforcement, then the maximum is a 4%. 0.4 BD. BD means percent. If you will convert in percent, it would be 0.4%. 4%. Sorry, not exceed 4%. So 4% means 0.04. So 4% we have to write. So where it is that? 4%. So 4% means 0.04, and the nominal speed is nominal steel. Nominal steel also it is 0 point, because it is the tension side. So 0.17. We are not going for the crack width. We had also ignored in the slab, so we cannot disturb this. Nominal still percentage, minimum is still take. Now we can select the grade of concrete. For beam also I am selecting M20 and FE 500 we are selecting from here. For stirrups also FE 500, and bottom top clear cover. For beam I am taking 25, side clear cover 25, maximum aggregate size I am taking the 20, the size of the aggregate. And also prepare the bar. In case of beam, better to go with the 12 mm, and this is not related with the ductile detailing, so that is more than enough up to the 20. So also this SARE rebar is going with that 8 to 10 mm is more than enough, and then side face reinforcement is also 10 to 16 mm is more than enough. Then stirrup spacing, I am providing here the minimum spacing 3 inch near to support, and maximum spacing we are going with that is 150. That would be more enough. And round up, I am doing everywhere with 25. You can do and check yourself. Okay, what is the effect is coming. Different rebar, leave it this. We are not interested to the provide the different rebar inner and outer stirrups. Then click and OK. Then design, sorry, not design. Then go to the rebar curtailment. Also, we are not actually interested in curtailment. Why we have to interested in curtailment? Why we are not doing any kind of curtailment in beam? We are not providing any kind of curtailment. So we are not interested. So also it will not affect so much. So leave it that. So then again we have to go for the detailing and drying. This is the detailing and drying setting. Ki how much the LD value, minimum vertical for L bend and development length value. It's better to go with the fixed length value. No, development length, that would be better. And then actual value you have to click. And we are coupler for the lap and splices. कहाँ गया वो? सिद्धार्थ? सिद्धार्थ कहाँ गया? Use coupler for the lap and splices. Okay, you can also click and you can use this. Okay. हाँ, नहीं, कपलर अलग चीज होता है, बिल्डिंग अलग चीज होता है. Also, we can go by the mark unique section, also spacer rebar, or round up. I am everywhere doing the 25. The you cannot disturb the center to center. Always go with the clear span and provide the curtailment from the top bottom support face, not the support center. Be careful about that. Then mark curtailment all the from the support page. Do not disturb anything. Rebar mark manager also you can change for the main bar. The give the dia T the share also is better to main bar. You have to give the diameter D, or no need to give the diameter. Why to give the diameter? It's better to give diameter D. मेन बार शेयर के लिए also you have to give the, or you can change like that. 25 25 is the dia of the bar, and 4 leg, or 25 kya 25 in number, sorry, 25 in number. You can also change from here 4 leg. So it's better 4 leg diameter is 10, and at the rate 120 center to center. Why should I provide the number? So you have to give this here D. You can change as per that, and then you have to just go for the side face reinforcement. In place of this, it's better to write side face reinforcement, and then this is the D. And also you have to click the OK. This is only the presentation, not I am doing. You can do the presentation as per your, and then click OK. And then anything more required, paper bar spring, basic load cases, only 2 load cases is there, so you have to go from here and import load cases for combination. No, I'm not interested in that. So import from template, whatever the template given in RCDC 1.a. You can also select from the analysis, or better to go from here and click OK. So it has been also basic load combination they had prepared. And then go for any other thing. No, then go for the design, auto design. So it will design the beam. So it design the beams, and you can save this by stat file, not RCDC. In beam you have to go and save this as a beam. So I have saved the project. So now you can see here, when you will read this, the beam B1 B2 group. Here this B1 B2, the group is there, and now this is the reinforcement table. You can simply copy this table and paste in Excel. Just click here, somewhere you can click Control A, something like that. Somewhere you have to click, then it will copy. Why not copy? Copy table and then simply paste in Excel, simply. But in case of beam we are not providing this table. In case of beam we are providing the diagram. Be careful, we are providing the diagram. So this table also, the bottom left, mid, bottom right, top left, top mid, top right. So simply na, bottom left, bottom mid, bottom right. Sorry, what is that? bottom left, bottom mid, bottom right. हाँ सही है. Bottom left, bottom mid, bottom right. Fine, fine. Top left, top mid, top right. And then this is for B1, and then this is for B2, and this is the share enforcement. Share left, share mid, share right. Because we are not, see here 125 here, 150 at the center, because the here the share force is going to be very less, and at the support it is very high, so spacing is 125. In that case also 125, but here it is managing with the 150, so that's okay. You can also, if you are interested ki your labor should not confuse, you can also edit this thing as per your requirement. You can go and say, I think edit here also. Quick detail section, quick elevation, copy and I think copy and paste enforcement we can do like that. Let me check. Control C and then go to here and paste enforcement. Done. Copy reinforcement and then paste reinforcement. We can check. We can change. Okay, copy paste and we can change this. So, but in this case, our drawing is important. So, what? How you will get the drawing? To go to report text schedule. Also, you can get by this. You can don't select this two option. The first option, left and top and bottom, and when you will click, it will give you the this table. Okay, this table you can edit like that key 125 125 also. If somewhere it is going with the 120 here 150, so you can change this to the 150 okay, 150 125 125 50 and 125, this is also fine. If someone is looking like odd, so you can change. So mason should not do the mistake on site, but you should not increase, you should decrease. Be careful about the stirrups and other thing. Decrease the spacing between the center to center. So this table also, but also we can go with the other thing, elevation. This design summary, design calculation, same like earlier. This is important. So elevation and section. I am just going with one of the, okay, select all and all the click, then it will give you the, also you can, you have done all the detailing how to it will appear. So already we have done, so fine. And then simply okay, so it will create you. Not created. Okay. Report. Then कहाँ गया? Design summary, elevation and elevation. Select all. Select all. And then okay. So see, it is very coming very nicely. See here, all the cross section, all the things, the how much bar at top, how much bar at bottom. If some lap is there, the top reinforcement and then lap is there, so where we have to provide the lap. The D20 is there, how much distance, 660, the lapping length, and also from the support of the column, face of the column, where we have to provide the lap. The everything is there in this diagram. We have to provide this diagram to the client. Actually, this diagram, everywhere the diagram, we have to go to the our AutoCAD file and we have to arrange 1 2 3 like that. We have to arrange and take the print and we have to provide. Also, we can take the print up completely directly all print and we have to provide. So this is the beam elevation. So we will save in beam, and this is the beam elevation. Fine. So beam elevation, then we have to save this, and all in AutoCAD you can open and you can see everything. You can go with that. Simply, it is very, and cross section is also there everywhere. The top bar, bottom bar, if any kind of stirrups is there, and then dia. If any the side face reinforcement, usually side face reinforcement you are providing when the depth of the beam is more than 750, 750 and more than 750. So like that you can do the design of beam. Um, Bill up quantity, other thing like same earlier we had done. Bar bending schedule also you can do by yourself. The reward tag manager you have can do everything. And when we will generate the bar bending schedule, it will generate the bar bending schedule as per your requirement. But it is not so much important. The same thing, same diagram is coming, but only here the cutting length is there. What the bar, how much length we have to cut. if B1 B2 and T1, so T1 is somewhere definitely T1. This is T1, so if we are cutting this, so cutting length would be of T1 is cutting length 2770, and in that how much part we have to bend, and the meaning of R, this is the radius of that circle where it is bending. Okay, कुछ कुछ लगा कि आज कुछ सीखा जो 3 साल में नहीं सीखा? हाँ, कुछ लगा कि यार बहुत कुछ है जो छूट रहा था। हाँ, होता है ना कि बहुत कुछ लगता है ऐसा छूट गया जीवन में। हम्म? लग रहा है बहुत कुछ छूट गया। कोई बोला उधर। And also you can see at the bar also you are getting the weight. So directly you can multiply with the per unit weight rate, and you can get the value how much money we are going to spend. In simple single click for one beam, summary B1 B2, if you will click select all the beam, it will give all the beam here. So by this way we can do the design of our beam. Now I had not taken any secondary beam because everywhere we had provided the column. So secondary beam also we can do here in RCDC. Slab also we had taken here. So we had gone through lot of things. Analysis we have done, then slab design we have done, staircase we have done, then beam we had done. Now after lunch we will go with the uh, what column and footing. So most probably by volunteer, volunteer. Now I am saving everything. Now cutting this, and I am pause the recording. That would be better. Continued, and then minimize point. So we will on RCDC. Again we have to on this RCDC run an administrator. बात ना करे, volunteer please take care for 90 minutes. If you want to finish this, please cooperate. Then no need to disturb anything, and then just go for the accept. And again you have to give this column RCC column RCC column. The client is XYZ, and the engineer XYZ, and engineer is self. I am also engineer. The code already I taken IS 456 and for ductile detailing, but here we are not interested in ductile detailing. Next time when we will go for the 5-day complete session, there we will go for this ductile detailing. So here we have to again select our stat file. So event day stat file, and this is our stat file. We selected, and again we have to go for this column and share wall, but in our case no share wall is there, so only column we have to design. Create project, it is doing the internal processing and reading the analysis data. So after reading the analysis data, okay, we have to sign in. Let's check. It's doing the internal processing, and do not do anything. It will read and see the column. He has placed all the column. Now we have to design this column. For designing of column, design input, lot of tab is there. Column reference, column size, level data. Then shift of CG. If you want to shift the, if you want to shift this column from one location to another by some amount, but that is not needed. I will tell later why it is not needed. Then then frame type, what type of frame we are selecting. So first the column reference, then 0 from ground story it is taking 3 meter, then 6 meter, then 9 meter. And then here the M25 grade of concrete for column M25 FE 500 we are using, so FE 500 we will use. Either you have to do this or just do in one and copy paste. अरे मत कर भाई, वो आवाज मेरे को गूंज गूंज के आती है. In case of column we are keeping the cover 40 mm, and if we, actually column is connected with beam, so whatever the beam parameter beam material we have taken we have to also provide it here. So if M20 we had selected for beam and covered M25. So after that column reference, then this is the column reference. Here we will click, it is clicking the column from 0 to 9 meter. All the columns is written given here. We no need to edit here anything. Then column size is also given. Later, if any column is going to fail, then we will change the dimension and reinforcement, other thing. Level data already we provided. Now shift of CG, we are not interested to shift the CG of the column, because here just we are interested in the structural design. Actually the placement is the architectural part. Now frame type, non-ductile. I already told you we are not here to do this ductile design. Non-ductile we will do thing. Otherwise we have to change from here. It will be lateral gravity or non-ductile. So lateral we are not interested. Non-ductile we are going to do. We can also save this layout, column layout, just clicking this save. First we have to save the project. From here we have to save the project, and we will save in RCDC and column, and here we will write the columns and then save. So now we can also save this column layout in column folder. You can say right layer column layout. You can give the this thing to the client if you are interested, or client is interested. Here the center to center distance is given, and also the column location is given. You can also use this for the marking on the ground. With the help of this you can mark the column on the ground also. This is possible. So go to setting and then design setting first. Here it is asking for the design setting and ductile setting. So here we are not interested in this ductile. So we will not do response reduction factor. Actually we are not interested here for the earthquake. So we will also not touch this part. And joint check for PMAX or for all loading combination, that would be better. Actually, we had not clicked, so it will not read all this data. So no meaning of this. Live load reduction also we are not interested here. Effective length factor, it is important. In IS code, the effective load factor, effective length factor is given. Key both end is fixed, one end is fixed and one end is free. If you will see the code, it is given in code at the last. Column effective, yeah, this if both the end is fixed, our recommended value for the effective length is 0.65 L, so we have to put this value. Okay, so in case of RCC structure we are assuming ki both end is fixed, so we have to put 0.65 L. So here we have to put, we have to go there, and here first we have to just select all the load and transfer here, then okay, then next window again also regular structure, our structure is regular, then okay, then this is coming. Here it is 111, but it is not going to be 1, 0.65 as per code. You just click this, it will convert to 0.65. Now effective length. So now okay, and then after our column is not braced, so we will not also take this. Modular of rupture check for axial tension, fine. Ignore intermediate beam for merge level, and no need. Optimum design, yeah, optimum design we want. And consider cylinderness effect. Also, we are designing the column for cylinder value. So, what is the cylinder value? L effect, L upon least lateral dimension. That is the cylinder value. The length of the column and least lateral dimension. Also check that maximum capacity. The maximum capacity, it means it is asking for the beam column capacity. This is very important. Actually, beam column capacity should be less than 1. What is the meaning of that? If your beam column capacity would be less than 1, it means you are going to design weak beam and a strong column. And also in real world, it is demanding you have to design weak beam or a strong column. Why we are interested to design weak beam, a strong column? Why? Because if one beam is failing, our structure will not fail. But if one column will fail, our complete structure is fail. So we can say like that, column failure is global failure or beam failure is local failure. So local failure we can manage, but global failure, complete structure will fail. So this should be keep in mind, and code is saying that this value should not be greater than 0.7, but sometimes we are designing to also we are keeping 0.9 or less than 1. Okay, so I am just going with this 0.9 value. Actually 0.7 we have to keep, but 0.9 okay, as per the, because lot of factor of safety we are considering for the designing purpose. Then we are designing this column for interaction method. We know PU-MU interaction diagram, and with the help of that, we are designing this interaction. Sorry, column. Shear wall we are not designing, so no need to just do this all thing. And simultaneous minimum eccentricity check also we are doing. We know that our no column is going to be completely axial. Definitely there would be some moment will come. So we have to also check minimum eccentricity, and then uh, crack width I am not checking for anywhere, so I am leaving this. And material property, material list, nothing is required. So now just click OK. Now save. Then go to the setting again. Then reinforcement setting. Here the reinforcement setting. We know in column the minimum reinforcement is 0.8 minimum, and maximum is 6. But we actually, when we are providing the reinforcement, we are providing maximum 4, because we will provide the 6% of reinforcement. We could not be able to place the concrete very easily into the formwork. So that's why we are providing the 4%. Shear wall we are not doing anything. Leave this shear wall. Longitudinal rebar spacing. The longitudinal rebar spacing mean in cross section, the like that any cross section is there here, not showing any cross section is there. So one bar is distance of one bar from the other bar. The minimum value you cannot put 25. I think if I will put 25, it will not accept. So it's 50. It is accepting. So at least 50 you have to put. And maximum also you cannot keep so much, because 50 is more than enough distance between two bar. So also you have to put here the 100 is more than enough, because your column size is 350 by 350. The cover is 40 by 40, 80 is gone. And then also, so it's better to put 100. Prefer rebar spacing. It is like that ki, we have to divide the cross section in three zone. Zone 1, zone 2, zone 3. How can I make this diagram here? That is the main issue. Mid zone, and then zone 1, zone 2. Let try. If this is our cross section of the column, and our reinforcement is placed like that, is a Doraemon ban gaya yaar. So we had divided this into three zones. Like if it is from one direction, it is zone 1, zone 2, and zone 3. So zone 1 and zone 2 is the zone 1. Sorry, this is mid zone, and this is zone 2. This is mid zone. So mid zone equi-spaced, it means कि everywhere the prefer rebar spacing would be prefer rebar spacing would be 125, but we are going interested for the 50 and 100. 125 it will not take, because here is the 50 and 100, so 125 will not fit in this. So we have to change this value, then it will be better. So here it's like saying like that zone 1, zone 2, or mid zone. If zone 1 we want ki spacing between zone 1 is would be 100, and zone 2 also uh, 150 this zone and this zone 250. It is not a good practice. We have to give this better to place equi-spaced. So we will keep this 75 or something like that. So we can see it is working or not working first. So we have to put the value here equivalence. Here is not accepting. Why? Because here it's saying maximum value we have to keep 150, because here is zone 2 is 150, one minimum 150, permissible range is 150 to 600. Why maximum is going with this? If I will put here 100, then 75 it will take. No, it will not take. We have to keep this 150 at least, and then here. Then also it's not going beyond value beyond permissible range specified. So this mid zone is also we have to go with this 150. So it's better to put everywhere 75. That would be better. 75, 75. I am interested in equi-space. So better to place 75. Okay, so everywhere this distance to this distance 75, this distance to this distance 75 everywhere. Link spacing key stirrups, the distance between the stirrups, like beam we are providing the shear reinforcement, so here we are providing the tie stirrups. So stirrups we are keeping like that 4 inch. We are actually ductile detailing we are not doing, so basically 6 inch, 150, and also for the maximum 156 inch we are providing. In column, the minimum reinforcement dia is 12 as per the code. We cannot provide less than 12 So 12 we are providing, and maximum we are going with this 20, because it is only G plus 2 structure. That is not more than that. Shear also we shear reinforcement 8 or also it is up to the 12. That would be more than enough. And link link rebar, this is shear wall. Sorry, link and other things. It is not required. Shear wall, rebar. So shear wall we are not providing. Link rebar. Link means if any kind of link we are providing in the column. So also the 10, 8 and 12. Use bundle ductile link. We can provide the bundle ductile link. Bundle means at the one corner we are providing more than one bar. So that is the bundle kind of enforcement. Leave it now, right now, and we are providing the link like that. After when we are closing, it is going with the 45-degree inside in column, and tie also closed. Hoop wall we are not providing. In wall also we will provide like that. Or main link with the boundary element, it is for the shear wall. So for our case it is not the, we are not providing the shear wall, so we will not touch this. This is the actually the master link, the main link with the boundary. When we will learn shear wall, then we will see. Right now, leave it. Round up factor 25, zone round up everywhere. Everywhere I am placing this. You can change and check what the changes are coming. Now design detailing and drawing setting. Provide first slab below plinth. So no, I am not interested to provide the first slab below plinth. I don't want, so it should place below plinth. Display material properties. If you want to see the material property, you can click display lab dimension, fixed text. No, I don't want fixed text. I want the actual length. And provide continuous section number. Yeah, I am interested in that. So lap it each level. Yeah, I am interested in that. Lap I want to see at each level. Reinforcement level, use rebar, prefer tag, use both. This is the detailing kind of thing. Whatever you want, you will tick here, it will show. It is not related with the design, it is related with the detailing. And use level description. From here, the reference level is 0, and then it is going up to the reduced level. If I use level description, that would be better. Whatever the level description we given, that he should follow that. Rebar mark manager, again the main bar you have to give the dia D, capital D, and then in case of shear also you have to provide D and at the rate center to center distance. Foundation data we don't have, so we had assumed ki our foundation is 600 depth of the foundation is, thickness of the foundation is 600 depth, or what column mark, then depth of the foundation, because we had not designed the foundation right now. The rebar reverse splice at the mid. You cannot touch this all thing, and this same location lap is equal to LD development. Whatever the development is length is there, you have to provide like that. Staggered we want. We don't want at same location. We have to provide the staggered. Staggered means if some kind of reinforcement is like that, and we are doing the lap here. So next this reinforcement lap we are doing. So another we have to do it's not at the same location in one column. So that's why we have to provide the staggered kind of lap, and then just click OK. The next is zone and rebar setting. Don't disturb this. Again, it will make you confusing. Already the zone 1, zone 2, and mid zone. Already we are provided with the equal spacing. Then merge column. No, I don't. I'm not interested to merge the column. It should design separate because it should be clear. And then basic load case. We have only two load case. Then click OK. Then OK. And then take from the regular structure and 1.5 dead load live load for the strength, and then again go for the load combination already defined. uh, so fine, okay, and then for anything more, no, then go for the design, and auto design you have to do, and it will design the column, your all the column. PT percentage 1.11 is coming. It is quite good. It should be greater than 0.8 and less than 4%. It is coming 1%. Up to here somewhere the load is maximum here. And you will click, it is 1.4%. Capacity ratio in flexure is zero point 0.1. It is very good. See, it is going to be 0.8. But no one is designed more than 1 because we have taken the limit. Otherwise, it should be fail capacity. Uh, then column, okay, fine. We have to design the column. Here, all the details is given. But this is we are providing the column. In case of column, we are providing the cross section to the client at each level. So for that, we have to go to this report. Text schedule is simple. When you will go for the ductile or non-ductile, I am interested in non-ductile. So this kind of table is coming. So if you will see the C1 column, so height from 0 to -2, those size is this, and the steel we had provided 12 in number of dia 12 mm, and distance stirrup spacing is 8 mm dia 150 mm center to center. But we are not providing this table also to the client. We are simply providing the cross sectional detail, and up to the top the reinforcement details are given. So by this way you can design the column. And next, if we will see the report, detailed drawing is also not we are not interested to provide, and I am interested from minus to bottom of the foundation to top. So click OK. It will give you all the cross sectional detail. Cross sectional detail. This we are providing. This we are providing to client. Okay, like that here, if this is C1 column mark, and 0 to -2, it means pedestal column below the ground level, and cross section is this, the bar location is this, and stirrups we are placing like that. Only we are providing this table. Also we can merge this. We will merge the column, same cross sectional will come like that. C1 C2 like separate, no, we'll merge like that. Modify, group the column, auto group column, and go to auto group column, or then it's fine, auto group column. Okay, now it's reduced to only this much. Now you if you will go for the detailed drawing, now it would be very less. You just give this value, because up to this much column only this cross section we are providing. So it is very easy. You have to just save column detailing, cross sectional detailing. So column detailing, and simply you have to arrange in AutoCAD and make the report and give to the client. Simple, very simple. Only this thing you have to provide. So in slab you have to provide the text schedule. In beam you have to provide the longitudinal cross section. In column you have to provide this, and in foundation also no need to provide everything. Only you have to provide the reinforcement at top and bottom. Simple. and one kind of beam column connection you have to provide in separate sheet. There you have to write the simple key L by 3 or L by 4. You have to go for the special kind of stirrup. If you are going for the ductile detailing, then we have to write only the stirrup spacing is less than, for L by 3 we have to provide the less spacing of stirrups. Otherwise, if you are not interested in ductile detailing, everywhere same spacing. So again, in report, design calculation, design summary, and design for all load combination. Let me check what is this. Okay, this will also give you the design, and then snapshot. Then bill of quantity. If any kind of bill of quantity you want to interested, like previous, you have to put the value and it will give you the bill of quantity. Let's check. It's the bill of summary, reinforcement level wise, and then you have to give the plan area. It was 15 as 135, and rates you just take from the market, and this 500. Okay, fine. M25, and then okay. So it is giving key you have to make complete all casting of all column. It is going approximately 6 lakh. So six lakhs, and then labor cost. Labor cost would be 50% more, so it would be 9 lakh. And then after 10% wastage, it means approximately 10 lakh. So 10 lakh is the total expenditure for the casting of column. So 10 lakh in column, and in slab it was approximately 18 lakh, 18 to 20 lakh, 30 lakh. And in case of beam, we calculated, no, we not calculated, but it would be also approximately 10 lakh. So how much? 40 lakh, and then after foundation will also take the 8 to 10 lakh, so 50. So this is the approximately 135 into 10 and 13 14,000 square feet only frame structure with labor cost for everything. It is going to be of 35 to 40 lakh with all the labor cost, with all the material. It is approximately the same rate in the market. Now you can optimize the thing, but it depends on you how to optimize the size and dimension. You can also play with that here. You can reduce the cross section size and column dimension. Now you can also change the size of the column, and you can go with that. For that you have to unlock and you have to change the other things. So report bill of quantity, then bar bending schedule also you can generate. This is the uh, presentation arrangement, so you can do by yourself generally bar bending schedule. And here I want interested to all, and then no need to touch other and generate. So it will give you the bar bending schedule of the column, ki how much, where you have to bend the bar, where you have no need to, you have to bend the bar, and how much cutting length would be there of the bar. You will get all the details in this bar bending. So it will take time because I selected all the column, so it will take time. So we have to wait. The all the bar bending schedule very short. Why we had gone with this all? It's better to go with one. So here the total bar. See here the staggered form he provided the lap, and lap length also, how much lap length is there. It is given here, and in place this lap length also, when we are tying with the stirrups, we are keeping the spacing close. So it should be sustained the earthquake, but in our case no earthquake, so no matter. One more thing is their report, then design summary, design elevation also we can generate. For one column I will generate, not for all. Otherwise again it will take so much time. So same thing, the staggered form. The bar bending schedule is the detailed form of this what elevation bar bending. So in case of column, here you will also get the cross section of the column, single column. Okay. When you will merge, then maybe it will come with the merge. Let me check. Report, then elevation, and then all column. It will come with merge or not merge. If client is demanding this diagram is so much column is there. If client is demanding this type of cross section, what you do? You have list. You have list key which column are of same dimension. So you just delete other and keep the same with one column. The C1, C2 and C3 are same. So just delete this, and here you have to write this in place of details of column C1, C2, C3. Simply, no need to give the all the diagram. But also we are not providing this diagram. Okay, we are just providing the cross section. That is more than enough. So by this way you can design the column. Now later you should practice, you should go through code, you should read the code and parameter all the parameter. Now I am telling you how I am learning. If I am after sometimes I forget something, so it's better to take the screenshot like that. If I have to fill this data, but I don't know. Lot of parameter is there. So I will simply take the screenshot of this and go to the chat GPT and I will paste there. I will say ki just tell me the suitable parameter by which we have to fill this value. Okay. And also tell me the clause where it is written in the code. It's giving everything. Go and read and study. Nowadays it is very easy to learn. Okay. Earlier it was very tough, but now it is very easy. If you are interested to learn, you can learn. So by this way we can do the column design. So what in col in it means in slab we are providing the text schedule, in beam we are providing the longitudinal cross section, in column only cross section, and in slab only the reinforcement, top and bottom reinforcement. That is more than enough. So now next we will go for the foundation design, and in foundation design I will just again close and then open this RCDC again where the RCDC and then run as administrator. क्या हुआ? नींद आ रही है? बस बस 20 मिनट और रिकॉर्डिंग एक बन जाएगी पूरी. रिकॉर्डिंग हो रही है ना? हो रही है. मैं तो कहा गया 3 घंटे की हो गई है. आधा घंटा और फिर ये आपको रिकॉर्डिंग मिल जाएगी. प्रैक्टिस कीजिए आप लोग. जो डाउट्स हो पूछिए. आप डाउट जितना पूछिएगा उतना मैं सीखूंगा. समझे? जितना डाउट आप पूछिएगा उतना मैं सीखूंगा. चलो आओ थोड़ा. तो वी हैव टू स्टार्ट अगेन. दैट वुड बी बेटर. नो. व्हाट वी विल डू फॉर आइसोलेटेड पुटिंग. अगेन वी हैव टू. अरे बात मत कर भाई. बहुत ज्यादा आवाज आ रही है. डिस्टरबेंस हो रहा है मेरे को. जैसे आप धीरे 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 धीरे. अब वो सीजी मेरा लिफ्टअप हो गया है. तो अब थोड़ा शांत हो जा. अब जैसा ही हम बोलते हैं कि हो गया था फिर चालू हो जाता है ये लोग. अरे रुक जा थोड़ी देर भाई. मैं भी साथ में बात कर लूंगा. क्या दिक्कत है? वो देखो लगा पड़ा है. अरे कैसे कैसे. Now recording is going on now. Recording going on. So that would be better. Fine, huh? Now we have to design, then accept simply, and then select from here STD file. अबे यार. Simply this is our STD file. One STD file, but play everywhere. Footing column, what footing? We have to design the footing, create project. Again the same concept key. We can also use the stat foundation, and in stat foundation also combined and mat foundation is possible. Okay, and isolated footing is much easier in this stat RCDC. Sorry, stat foundation. But we are interested to do here. We will click no. So all the things will come here, and we will design our isolated footing here. It is doing the internal processing and reading the data and analysis data, and then on the basis of analysis data he presented this window where the first column is serial number, then analysis number as per the number which is allocated to the footing in STAAD.Pro. Then column mark here, whatever the column mark and the footing mark is here. There are three type of isolated footing. Let me show what type of isolated footing is actually available. Actually, there was also one video of 1 hour, that would be better to watch, but all of you had not watched, so no matter. Then so it's better to go there, demo class, and this one is okay. You can see from beginning. If you will see here, the ETAB Stat Pro, actually you have to learn all this software, then only you would be become a structural designer or this other things. So if we'll go, these are the complete workflow, ki how the which file is going where, and what you have to design with this flow chart. That is the anatomy, and this is the two channel 1, channel 2. Either you have to follow this channel or this channel, and then after prerequisite and goal objective, then here this point. Now this is the central line plan, and then the 3D model G plus 3 and G plus 4. The floor plan is there, and the load, whatever the load we are taking here, the which software we can use. Then these are the analysis report. Then RCDC input. This is the meaning of ductile detailing. Here the anchorage length is very less, so it is not ductile. This is ductile as per 13920. Then RCDC we are using for slab input. Then slab marking. Then this is important. This is important to show the client. Then slab reinforcement, cross section, and other thing. Reinforcement detailing, staircase, we had gone through all these things. The detailing of the BBS of plinth level slab, bar bending schedule, then bill of quantity. Then again it's going with the beam. We had also done this beam, the beam where we have to place all the reinforcement and everything. The bar bending schedule also we have done this. Then go for the plinth, this is bar, yeah, what bill of quantity. And then for the column also we had done the column, and this column reinforcement from column mark with the similar group, and going from the plinth level to top of the headroom. Then again it's coming with the this is important to so give to the client this. And then bar bending schedule if he is interested, otherwise no matter. And then this is not actually important, this is shear wall, but in your case shear wall is not there. Shear wall with boundary element, the boundary element is also there at the end. The bill of quantity, and also isolated footing. So isolated footing we had provided, but somewhere the physical class is there, so we have to go for the other software. In case of physical class we had used the shape software, like that shape software, the this is combined footing. This is actually, there is the difference between combined and raft. Two footing combined, more than two raft. So this is not combined, this is raft. Careful, this is not combined, this is raft. Then the input parameter, and you are getting the reinforcement as per the shape. From the shape so software you are getting the top and bottom reinforcement. And then one more thing is there, isolated footing. Here we are providing the design detailing of, actually this is not, actually this diagram, that diagram is not here actually. Only this diagram is only necessary for the footing. Only this diagram, column, top reinforcement, bottom reinforcement, finish. If you are providing the bottom and two, in bottom there is a two layer in x direction, in y direction, and top also you are providing a reinforcement. But in isolated footing we are not providing the top reinforcement, we are ignoring generally. So like that also you can provide the reinforcement. And after that, see is these are the some things you can achieve with this all thing. Now I have only followed the gravity load. I had not gone with the wind, and I had not gone with the earthquake also. Okay, so these are the advanced courses, and there is the solution with that. With this we can achieve everything. And also the modeling of these all the things in we can do by this. This is see footing. Footing you can see there is three type of isolated footing: the step footing, the slope footing with the 45-degree angle, and then it is the pad footing. These all are the isolated footing. Okay, you can go with anything. And also this is the on raft. There is a one feature also in RCDC. You can make the on raft foundation. This is on raft below the continuous shear wall or below the continuous wall. You can provide this on raft footing. This is the pile cap. Pile is there, cap is there, superstructure above. This is the pile cap also you can do in RCDC. So this is the combined footing and this is the raft footing or mat footing. Be careful. This is not raft. This is combined and more than two raft. This is the things, the detailing. Fine. This again started. This finished now. These are the codes. Usually we are using 875 part 1, part 2, part 3. Then IS 456, 1893, 13920, and then these all things. So very fast we will finish this our isolated footing. That would be better. So here we can go with three. All three we will select. Let's see what is going on. The second we are going with the step and third, or keep other pad footing. And the column offset in case of slope footing, we have a need of column offset. And leave it that other things, the raft thickness and other things. Let's see what the things are coming. Now go to setting, general setting. Here the use gross SBC, soil bearing capacity. Consider overburden pressure. Overburden pressure means surcharge load. We can say like that. Here, if this is the footing, this is the footing, and this is the ground level. So this here at this location, some soil is there. This soil will create some kind of pressure. This soil will create some kind of pressure. That pressure is going to be all going to be your surcharge load. You have to calculate if soil density is 20 kilonewton per meter cube and this height we had given 2 meter, so 20 kilonewton multiplied by 2, or this would be what 20 kilonewton per. So how much the pressure is coming? 20 kilonewton per meter cube into 2. How much? 40. So 40 you have to place here. So then 40 kilonewton per square meter surcharge load is coming because of this extra soil is making the pressure on this foundation. Okay, this surcharge load we have to create. So surcharge load we are applying. Someone is ignoring because it is very nominal. So that is not a big deal. We can also ignore this value. So I will also ignore use gross BC, and also we will not provide the top speed, but check for sliding, check for buoyancy, and check for overturning. This three thing is necessary, and use SBC, soil bearing capacity, and net SBC the value. Actually you have to do the soil test, agar bore test or pile test or some kind of plate load test on the site, and you have to find out the SBC. This is the work of geotechnical engineer. They will provide you the value of this SBC value, and also sometime the varying SBC, but we are keeping like that key near to that. Someone is saying 20 ton. 20 ton means when you will convert into kilonewton per square meter, it will come into the 200. So approximately 13, 10, 12 like that. The SBC net SBC we are getting with the medium soil or to soft soil. So I am just keeping the 12 ton. So 120 square per meter. You are keeping this value. Soil density 18 kilonewton per cubic meter. Foundation depth you can change here. It depends on you. We earlier taken 2, so we will also take 2. Okay. Foundation depth from the ground level or plinth level to bottom of the foundation. It is 2 meter. Water table we are not expecting water table, so we will give this water table 4 meter. So that would be better. Frictional coefficient 0.4 is usually factor of safety for sliding and factor of safety for uplifting. As per code, IS code, it is taking. Average pressure you have to go with this factor SBC 1.5 into SBC. And permissible loss of contact, I don't want, there is no loss of contact in my case. and concrete grade I am using M25 and Fe 500, and then clear cover we are using 50. And live load reduction, yeah, I need the live load reduction of 50%. Type of soil medium, SBC increase during earthquake, yes. Usually during earthquake the soil bearing capacity is increasing, even wind pressure is there. PCC below the foundation we are placing the PCC, plain cement concrete, and keeping the thickness, I am keeping the thickness 100 mm and offset also 150 mm. And dimension setting, plain round off, it's a round off thing, kind of thing, it's a 25 is enough. Maximum steps, if step putting is there, so maximum step is 5, or maximum depth, minimum depth is 300, maximum is, why it is written in opposite, let me check. Maximum step, okay, maximum depth is 0 mm and minimum depth, let leave it and then see what is going on. Set the plan, it is no need to, this already there. This we have to see why this is like that. Fine, okay, let's see, keep it like that. And now we have to see the things. Okay, now setting any other reinforcement setting. So also like slab also we have to provide the 12.12% of steel, and minimum top and maximum bottom. Maximum top is like that. Face reinforcement we have to provide 0.5%, and rebar spacing 100. Maximum longitudinal spacing I am keeping the 6 inch. And shear steel also 100, and maximum shear steel it is 300, that is more than enough. So 10 mm enough, and main steel I don't want to be go beyond so much, because our structure is not so much heavy. G+2 is there. Shear also we are going with up to the 12, and side face reinforcement also the 12. So other you can off from here. If you want you can off. So now crack width we are not checking anywhere. Basic load case. So you have to go and click this. It will come this side, and then regular structure, and then okay. Slim, please. What happened? For regular structure, okay. SBC is saying for the sliding and other kind of thing. Okay, fine. Then design, auto design is there. We are doing the auto design, and now it's C. It's design of isolated footing. Here the physical class. See, here the physical class, all the pad foundation. He designed the slope foundation. A step footing is no. He is not. He did design the step footing. There is no step footing. Is there any step footing? No. Slope, pad. He didn't design the step footing. So you can design either isolated footing. You can also convert this into the slope footing. That would be better. Slope is better than anywhere, any type of footing. Here also the physical class is there, so we will do the combined footing. Sorry, raft foundation. Here also is better to provide the raft foundation, because there may be the, maybe not physical class, but inside the soil there must be the pressure class. Pressure by one foundation and pressure by other foundation will clash each other. So better to provide the raft for this raft, for this raft, and for this raft, and here also. So what we will do for providing of raft, we will use another kind of software, either STAAD foundation or SAFE, so that we cannot covering here. We will, or one solution is there. You have to go and check where the reinforcement is maximum and which dimension is bigger. You have to provide like that, and use the reinforcement of this where the reinforcement is better for other. Like C1 this column, C2, no, C1 then C4. So C1 the FE, the dimension is this 400, and the 400, 450, 425, and then this dimension is 350, and this dimension is 425. So better we have to provide this 425 for this three, and we will provide the reinforcement which is maximum T10, T50, and this would be also T50. Again it's gone there. T50 everywhere T50. So we will, what we will do, we will keep the dimension of this, and we will provide the reinforcement as per this, top, bottom, and top. Simple. Only this is required. So report you can generate text schedule. So text schedule it will generate vertical schedule or horizontal schedule, whatever the face of the column, then footing, length, breadth, height, the D1 and D2. This slope putting. That's why the D1 and D2 is there. Along B, along L, we have to provide some footing is like that, but it's better to okay, you can use this table also, but it's my suggestion to go for the detailed drawing. That would be better if I am going with the detailed drawing, and detailed drawing not section, only plan. So that would be better. So in plan C, in plan bus, only this is enough. Only this is enough. In case of putting, this is enough. Or either you can group also, maybe group also you can do to modify. Yeah, group on group option is there, so you can group and group by ourselves. Auto group is not there, so we have to group by ourselves. So group, this group similar type we have to group, and then let's see what is coming. They are grouping or not grouping. Now create group. It's not created. Let's check. It's all grouped. All grouped. It's depend on us. We if we are interested to group, we can group, or if we don't interested to group, we have to just check. We have to arrange as per our demand. Group design, edit, then detail, ignore column, no report. So design summary, detail drawing. Now only one thing is there if L or B and everything. So all the putting you can do. The this is the longitudinal cross section. Simply this is the PCC, and then above PCC this is the RCC, and this reinforcement we provided the column which is coming and going inside the foundation. This is from one direction and this is from another direction. This is the plan. Actually only this is required. Okay, other thing is not required. And also the layout is already classes is there, so you have to go with the combined footing or raft foundation. So like that we can say like that ki column size change, failure diagram, bill of quantity. Other thing is also you can generate the bar bending schedule, and just go for the generate BBS and just click here. So it will generate the bar bending schedule. So this is the bar bending schedule. Ki what the bar, this bar is there, cross section 1. So see this length is given B1 and B2. B1 is provided like that. Where is given B1? Written anywhere? If B1 not written, then why it is writing B1? Okay, this is B1. The B1 is this, and B2, which is B1 and which is B2. It is given B2. Okay, B2 from here to here we are providing the B2 in that direction, and B1 we are providing in this direction. So B1 is provided. So B1 value this direction, this bar is B1 from coming here to here, here and there. So B1 here is given B1, the bar number, the rebar dia, and the bar total length. Total length is this, A is this, B is this, C is this, and R, you know what is the meaning of R, and total also bill of quantity. Let me check the bill of quantity for the foundation. Just simply area, plan area 135, and bill of quantity everything I need. So let me check what is the value coming. The bill of quantity 10 lakh, approximately 11 lakh. Also we predict like that. The and we also increase the size, so maybe it will affect the total quantity. So you should practice. I was a very short duration, so I cannot go everything in very much detail. So I can give you a whole picture. Now you should practice. Now you have recording and everything. Any doubt, you come and discuss. If you will discuss me 100 times, it will benefit. It is going to benefit me. 100 different difficulties I will try to solve. Okay, so practice and discuss. Recording I will upload in YouTube, and concerned volunteer will share with you the link. Okay. So thank you very much. And now I will let me save this. I don't go now. Don't go now. We are planning to leave, so don't leave. So because some closing speech will be come from the HOD side, or maybe convener side, convener the Deepsika ma'am. So you should wait for some time. So that would be better. And now let first stop the now stop recording.